It's me, I'm alive. I'm awake. Sort of. Bleh. Alright, how are we doing today? This is like an old Lee Mages mix, but it's good. I hope this doesn't get muted. I don't know if it'll get muted or not. Here's his Mixcloud site. Which one is this? Mystic Music Volume 1. If you're looking to listen to this, it's free. I guess. It's not rights free though. That's the problem. Is I'm just banking on whatever artists he's playing in this mix that was uploaded 11 years ago. Oh my god. 11 years ago. I'm hoping it's so obscure that Twitch doesn't murk it right away. My eyelids are droopy today. I am tired. I need to get to bed earlier. I'm very bad at getting to bed on time. Very, very bad at it. And I was listening to music last night and I just got wrapped up in it. It's looking good. This looks good. This one looks even better. Look at that. How cool is that? It's so much more readable than this. So much more readable. But for some reason, my printer decided that the buffer was too deep and it was unable to pause. And I wasn't able to do the second material switch. I don't know why. So it ended up printing too much, and this is just gonna bleed out if I put light into it. So I don't know what to do. I had to actually build the routine in whatchamacallit. I had to build the routine in Clipper. You know, I had to make the code work because the other one errored out because it had a I kept erroring out on prints because it didn't have proper code for what to do when an M600 was called, the filament change routine. But like, I don't understand why it was like, oh, buffer's too big. I can't do a change. I don't know why it did that, and it's gonna do it again if I try to print again. So I need to solve that problem. I don't know what to do about that. What's up, Justin? Let's see if I can just quickly Google it. Clipper won't M600 buffer. Are you streaming right now? What are you doing? What are you doing in my chat? What's up with this guy? Why is he here? Why are you here? Check to see if his stream is still active. What is this crap, Gonad? What is this? What is this? What are you doing here? Go stream. What is your problem? Freaking jerk. About to enable filament change. Discovered Clipper. He's not there yet. Code is to have an M600 G code working in Marlin. Blah 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 blah. This is like, yeah, this is 2018. M0. I mean, M600 works, right? I've got it in there. It just wasn't. It was saying that the buffer was too large. Can't make it through the first layer without pauses and cancels. That's not what this is doing. Clipper issue. This is gonna open in a terrible interface. Ugh. Get it. It's making me sick. Gross. No. Ah. I require information, not everything to look like fucking Twitter. There we go. Resume command with the terminal command extender plugin. Resume, hashtag resume, replace tag with an @ without adding it. What's that? When you pause via M600 on Clipper, you pause the firmware. Octoprint sees that, and a pause as well next when you resume the print via Octoprint resume button. It just pumps G-code into the printer, but Clipper thinks that it's still paused, so it'll come back weird because the saved position's in Clipper and not Octoprint. Okay, I did actually run into that. M600 lift Z, parks, unload filament, and wait for resume. On resume, it continues at the same height, and at the next level, it lowers itself back to the model. Second M600 is the same, except instead of waiting for resume, it just keeps going. Yeah, this is what I got. This is what I got. Automated M600 in the G-code. Okay, so terminal command extended. So if I do Octoprint and I go to plugins, wait, where do I get plugins again? I forget. I forget how to use this stuff. Where is that? Features. Where the fuck is the... It's not here, is it? It's in some other menu. No. Where's search for plugins? Why am I dumb, chat? Printer support, always there. Oh yeah, plugin manager, there it is. Jeez, that was annoying. And that was, what plugin was it again? It was terminal command extended. Okay. Oh, that's, okay, yeah. Huh. Terminal commands extended. I like this mix. I really hope it doesn't get copyright struck. How's everybody doing this Friday? Oh man, nobody's around. Usually I get more people at the very beginning of the show. That's all right. It'll pick up later on in the afternoon. Everybody's doing Friday stuff. I did too much Thursday stuff. Oh, hey, what's up, Cannibal? How you doing? How you doing? Good to see you. Restart now. Let's do it. Proceed. I feel like out of sorts today. I don't know. Part of it is just that I got to bed way too late. I just didn't get sleep. And I got stuff going on in the evening too, so I'm gonna have to end on time. We have a couple things to get through. This is one of them. I'll just get rid of start soon. Because I need to figure this out in order to get, hold on. In order to get the print going. So we can work on burn the subs more. Check out how this print worked though. I think that's the password. Yeah. I don't know why this Octoprint really doesn't need this, but here, check this out. It's a good mix. Yeah, I like this mix. Look at how readable that is. It's incredible. Only problem is that on second pause, nothing happened. So, yeah, I needed a 3-letter thing for AC. So instead of ACV, I just did bus and sus. Who cares? AC's good. Bus voltage is good. 24 volts exists on the end. 12 volts and then 5 volts. So those are all my voltage status lights, and I'll put some very dim LEDs behind these. They do not need to produce a lot of light. I just need them to be visibly illuminated. It'll be pretty cool. But I need my print to happen properly, which it did not. It did not. This one. Okay, so I did that. I got the plug in. No, it's actually 2 millimeters thick because I want the light to diffuse in it properly. These might get 2 surface mount LEDs on them, just so that it reaches the whole opening. But we'll have to test that. I'll have to test that with an LED on a PCB just to see what it looks like. They could probably just get 1, but I would like to have nice even lighting on it. But the thickness of the clear material means that it'll diffuse quite a bit. Just because this stuff with all the layers on it, it acts like a bunch of lenses. So it'll be pretty cool. I would have loved to see the final implementation, but I'm having troubles with Klipper not pausing. Put the commands as follows: resume and hash resume. Replace hash with @ it won't let me @ without adding it. Oh, that's okay. Resume and @ resume. What does this plugin do that I just got? Huh? Buttons to add to terminal tab. Huh? Huh? Resume. 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 Oh, and use this instead of the normal resume button in Octo. So, add the resume command with the terminal command extended plugin. Put the command as follows. And then it's supposed to be @ resume. Now, @ resume. Trying to get my printer to properly pause a print. Although I don't understand why this is anything different. I guess because of the way it pauses, it puts, when you pause via M600 on Klipper, you pause the firmware, Octoprint sees that and pauses as well. When you resume the print via Octoprint, resume button, it just pumps the G code to the printer, but Klipper thinks it's still paused. It'll come back weird because the save position is in Klipper and not Octoprint. So what I have to do is put in an alternative resume. Put the command as follows: resume, and then @ resume. Use this instead of the normal resume button. Okay. Okay, so now I can start the print with the pauses in it, and it should go through. Where's my camera on that? Okay, that's a decent enough. So right now I need to prime the printer because it's been, is it off? Turn it off? It might be off. Let's check. So if I go to Octoprint, I'll go to my Klipper panel. Oh yeah, it's not even connected. Okay, so I need to turn this thing on. Get my ass all the way over here. Turn on my printer. Get this out of here. And I've loaded up black, so we're ready to go. Should be primed and everything. Oh, it is, no, it's not on. Now it's on. Then I gotta reboot the firmware so that it connects. So I gotta hit connect on Klipper. That thing's attempting to connect. The screen should go turn on. Screen on. Screen on. No? Okay, reset the firmware. Why isn't the screen? There it is. Okay, now the screen's on. That means I'm connected. Now I need to put the BL Touch down. Didn't go down. Now I need to put it up. Now I need to test. Now I need to reset. And down again. Now it's working. Test again. Down, up, down, up. BL Touch reset. It for some reason it kind of sticks. So, all right. So now I'm ready to resume the print that I had with the 2 layer changes in it. So if I hit print, that's just going to start up, and we can move on with our lives. I have 1 unit of insulin left in my insulin pump, so I need to do a change so you guys get to see what a set change is like. Beep. Double beep. I know, I had a shrimp po' boy, so I've got lots of carbs in me right now that the pump is going to have to deal with. So, yeah, now that we got this rolling, I'm going to get the music out of here. I'm gonna get the music out of here. The music out of here. Music out of here. Where's the music? Where is it? Okay, I found it. Hey, that was a 20-minute intro where I didn't really intro. I'm not good at just random lab. I'm not good at that. That's not one of my skills. I guess it is because I'm a Twitch streamer. You got to be able to talk about nothing as a Twitch streamer. But I don't find the stuff that I babble about all that interesting. So. Is Klipper worth it? I like it because, I mean, if I want to alter like the base code of the printer, it's all one file. It's not an Arduino like set of 60 tabs that I have to fish out the setting from. And what I want is on there and nothing extra. There's no extra stuff that I have to deal with or read about or anything. And just the ability to have one settings file, I think, is worth it. But also, you can have, you know, 32-bit printer features on an 8-bit microcontroller because the microcontroller is not doing all that much. I happen to have upgraded the board to a 16-bit microcontroller. It's not really necessary for Klipper, but it has awoken things that my printer can do that weren't previously possible, and I feel like I'm in more control of it. I understand where all the settings are coming from all at once. So I like it. I think it's totally worth it. And if you're already running Octoprint on your 3D printer, you know, if the two are inseparable already, Octoprint's a no-brainer. So, or sorry, Klipper is a no-brainer. And you can use stuff other than Octoprint with Klipper, but I mean, if you have a Raspberry Pi permanently connected to your 3D printer, like, no-brainer. Just go with Klipper. It's really good. I've had good experience with it. So I don't think I'm allowed to show my belly on camera, so I don't know how much of this you guys are going to be able to see. But let's do a set change. We're going to do a diabetes equipment set change to kind of kick off today. We hopefully solved the problem that I was having with Klipper in that when it pauses for a filament change and I hit resume on Octoprint, it doesn't. Oh, there's tearing on the camera right there. Jeez. It doesn't actually resume Klipper. It resumes sending G codes. So the filament or the nozzle comes back and it tries to do all its stuff, but then when you go to pause it a second time, it just won't do it. It just won't pause. So weird results. But glad I discovered that. I had to get a plugin for Octoprint that does extended commands, and so now I have a separate resume button that will resume all operations and continue the print with Klipper running instead of just G-code sending. I don't know why that's a thing, but it is. So what the instructions were is to change just for the depth of the lens. So there would just be a clear stripe down this, and then I do the black filament again for the rest of it so that we can block light, because I want it to only look like this one is lighting up. I don't want it to bleed out into the other ones. But man, these turned out really good. This is super duper legible. Just one little layer change into clear filament, and bada bing, all of a sudden you got this really fancy looking thing. It's going to be a good little indicator panel, and it'll be facing this way on the wall, so I don't have to constantly see it. But now I have to get that to print successfully. Anyway, what are we doing today? Well, we're going to do a little bit of that, a little bit of this stuff. but that's mostly just being a hall monitor, right? I'm mostly just monitoring a print. So instead, I thought what we would do is look at some of the mechanics that go behind the insulin pump system that I switched to, and that is this giant adhesive, this thing isn't giant, it's very small. It's an adhesive electronic device that goes on your body and injects a cannula and then delivers a little bit of insulin throughout your day. Mechanically, inside of this thing, there's some really interesting stuff going on. They have some really, really interesting stuff going on inside of this thing. So we're going to try to take one of these apart. I don't have a hot knife. I wanted to make a hot knife that would work for opening the plastic of these things. We can do my normal method of opening a welded, ultrasonic welded plastic piece. We'll do my tried and true method, which is just to put it in a vise and squish it. That's all you do. You put it in a vise and you squish the shit out of the plastic, and it won't survive, but we'll still be able to take a look at it and see how it works. Now, it's interesting that I can kick off this stream because I had that fucking shrimp po' boy with all the carbs in it. I can kick off this stream by doing a set change. Set change is when you change out all your stuff, and you see them fucking all the carbs in my body right now. So I can go to my dash menu. By the way, this is the diabetes management program called Android APS, Android Auto Pancreas System. It's communicating with this program called XDrip. This program is a diabetic made Bluetooth low energy receiver of glucose levels. So this works with my Dexcom device, and it gets the glucose levels, and then it communicates with the Android APS system, which Android APS is monitoring carbs, the onset of carbohydrates, the amount of insulin in the body tapering off, and sort of the peaks and valleys of insulin that's already happening in the system, and it caters it to the data that it's getting from the other program. So the glucose levels are coming into this thing. We have a known amount of carbohydrates in my body, and then we have a known amount of insulin in my body, and its predictions say that my glucose level will probably do something like this, which it won't. My glucose level will go up, and it'll stay up, and then I'm going to have to give another bolus. That stay up thing that my glucose levels do, I need to program in an automation on this thing that will detect that and then give me more insulin. It's so very complicated, and all the settings are at my fingertips. It's great. I love it. It's kind of like Klipper. It's kind of like Klipper, where it is not overly simplified in order to cater to, you know, a super wide audience. This is for people who really want to grasp and control their glucose management within the system. So let's look at the dash pod right now. Reservoir 1.2 units. Well, I can tell you right now that injecting a singular unit will do nothing to me. So I'm going to inject 1 unit of insulin. So bolus, 1 unit of insulin, go. So now what it does is it's got about 30 seconds until it does its little communication with the pod. This is where the pod is right now. We got 30 seconds until it communicates with the pod, and once it does, you start hearing a clicking noise. There's a little subtle click, and that click is a piece of memory wire going back and forth and advancing a plunger. And we'll take a look at all that stuff. There's some really clever things going on in these little pods. Now, supposedly it's been calculated that this is about $30 worth of electronics, and this is disposable. So I go through these things pretty fast. I use a lot of insulin. Omnipod might not have been a great choice for me just because of the amount of supplies. These things are fundamentally non-reusable. You cannot reuse these. And the way that I've been extending these out, the way that I've been extending them is by bolusing straight up with insulin because I want to have extras. So this thing I've mostly made responsible for my in-between meal management. And when I actually do like the insulin stuff, like when I actually eat, I'll just inject instead. It's not a great system. I mean, I'd love for this thing to be doing all of it. How did I not know this existed? I didn't keep up with it for the longest time. And so I just recently, it takes about a month to do all the training on this stuff because it eases you into all the features. I just, I didn't know about it before I did that. I decided that I wanted to go with Omnipod, and I looked at the status of this stuff, and it's gotten really, really good. Because actually what this does as well, this will upload to the cloud. And so now I have this website that you could just go to and see all of my insulin management in real time. I gave my doctor my URL. Anyway, we're going to go to pod management, and I'm going to deactivate this pod. Why would I do that? That's because these things scream bloody murder when they're out of insulin. They let out a constant shrill beep. That's the beeper right there, that yellow circle. That's a piezo buzzer, and it emits just a constant tone. I don't know why they do that. Why do they have to do that? It's so annoying. So now this thing has to wait until all of its operations are done in order to tell it to pause the pod, and the pod will let out a little beep beep when it's done. Please to be stopping. Hello? It is me, your phone. Stop to delivering insulin to this man. Let out your beep. This is taking a little bit. It might error out. There's also there's a break point on the circuit board of this thing right here, where if you push it in, it breaks the circuit board, and that ends up stopping the shrill beep. Oh, there was a little beep beep. Okay, pod's deactivated. Next, finish. Okay, so this one's dead. This one is dead. I can peel it off. It's a giant adhesive patch. Ew. Did it take any hair with it? It didn't. It actually didn't take hair with it for once. Yeah, these little waterproof Jim Jams. But look at that little cannula tube sticking out of it. Now we're going to get a new one. Here, I'm just going to get rid of the gross Band-Aid adhesive. I didn't know that insulin smelled like Band-Aids, and that was a purposeful decision that they made. They made it smell like Band-Aids so that you would know. I guess. I don't know. Let's make sure they know. Okay, so, new Omnipod. Who dis? So they come like this. They got a little safety door on the front there, because this thing is a spring-loaded device. It is a very spring-loaded device. It has many springs that are all loaded. We get 200 units of insulin. Hey, 200 units of insulin. For every fart Turt sets off, I'm going to make Willow play with the turtle toy more violently. Yeah, welcome to Twitch, where you can see a man injecting drugs. Oh my god. My children will see this. Is that bubbles coming from behind the plunger or in front of the plunger? And the only problem is getting all of that sweet precious insulin into out of the bottle. It's always tough to do. Now I got like tiny bubbles. That's really going to be annoying. All right, so take this out to 200 units. The old classic flicking the bubbles. We're going to try to put the bubbles back into this bottle. Get them off the sidewall and then pop them back into the bottle. There you go. That's relatively bubble-free. One of the things that can happen with diabetics is if you fly in an airplane and you go through different air pressures, atmospheric pressures, those bubbles can expand and actually cause it to inject insulin, unbeknownst. And I've actually had that happen while flying. I went super hypoglycemic for talking to customs. Had to eat what was it? I had like one of those like hiking energy bars in my bag for like, it was like months and months old, and it had been like super duper crushed. Oh god, it was disgusting. It was like a cave bar or something like that. Anyway, so yeah, there's a little inlet right here, and it's got like a little rubber blocker on it that the needle has to get through in order to inject insulin into this reservoir right here. So that reservoir is unloaded, and once you actually start injecting, the whole thing moves down, and then it's captured by a spring. Very weird. Would it suck out interstitial fluid when the bubbles contract again? I wonder. I wonder what would happen. What is the atmosphere around the cannula? Isn't it like, I mean, wouldn't there be insulin around it? It would just suck its own insulin back in? I don't really know. But anyway, as I'm injecting, I'm going to get two little beeps from this thing. There they are. I really wish I could take this over 200 units. Cliff bar. Yeah, that's what it was. Not a cave bar. What am I thinking? It was like, I don't think it was a Cliff bar, though. It was different. You're not supposed to recap needles, by the way. The reason for that is something that actually happened to me one time. Not on this needle, this is a very small needle, but on a longer needle, if you recap it, it can catch on the side and poke out the side. So I ended up stabbing myself one time when I was recapping a syringe. Okay, so this is loaded up, right? Now what it's doing is it's communicating via Bluetooth low energy, looking for a host. So I need to activate the pod and click next. I filled the pod. I should have filled the pod when it told me to, but now it's going to initialize and these two are going to pair up. And we saw all this stuff when we were hacking Bluetooth for the steering wheel project. So this thing starts clicking, which means it's priming. You have to put insulin in all of the tubing first, and there was just a little click noise there. So what happens is it starts moving the spring, or sorry, it starts moving the gear, and when the gear gets to a certain point, it releases the spring that goes taut around a rod, and that captures it, so that when that spring when that spring moves, it's taking the whole plunger with it and advancing it and injecting insulin. This is going to be really cool when I get one of these open. These things are really interesting. So what I need to do now is break this off and get this ready to go, which means you guys aren't allowed to see, unless I did like behind the arm, but I'm not getting brave with the sights yet. I'll get brave with the sights when I have a lot of extra supplies. So I lift my shirt and I just put this thing on my body, and then I make sure that the adhesive is down. So I can't show you guys this part. I can't show you guys this part because Twitch is Twitch, although it would kind of be cool to get banned for that. That would be kind of interesting if I got banned for treating my diabetes on camera, because that would be a nice little controversy, wouldn't it? I'd probably pop off pretty hard after that, but I have a little bit of integrity, so I'm not going to do that. All right, initialize pod. It's paired. Next, attach. I did that. Next, attach pod. Okay. Now, the way that this thing signals for it to inject is simply by advancing the gear more. So that little ow that I just said was this thing clicking and the needle going in, coming out, leaving behind a tube. We'll look at that whole mechanism in a minute. So that's the cannula inserted. Next, finish. Pod is activated. So now I have in my pod menu, I know that there's 2.8 units delivered, and I've got about 200 units. It doesn't actually give you the number of units left until it's at its end, because it knows that when it makes electrical contact, or when a certain electrical contact is broken, it only has so many units left in it. And so it'll know when to start screaming at me. Pod status running, 0.5, 50 units left. We're good to go. So this thing is just going to continue to manage my sugars without my intervention. I've programmed it in order to do the things that I would do anyway. So that's cool. Now we can actually pretty much eviscerate some of these and take a look at what goes on inside. The mechanical stuff is interesting enough on its own. In terms of electrical stuff, I mean, it's literally just one chip. It's two chips. I mean, I think this one's memory, and then this one is the one that runs the show. It's got all the Bluetooth and all the drivers for everything, and then it's got just a bunch of spring contacts that give it all of its features. So very simple. They've pretty much simplified the amount of external components that go into this thing, because they're mass producing them and they are disposable. Can you believe I'm throwing out like a pretty nice microcontroller every single time? Because this pod is garbage now. There's no value to it at all. And I'll show you why. Let me just check on the 3D print. It is 3D print. 3D print happen. Look, go. 3D print, yay. Huzzah. Rejoice. Rejoice, for we are 3D printing. I don't know what else to say about it. We're just waiting on that pause command. Okay, back over to here. So, you have to fix something that's plastic welded together, right? I've got bad news for you. Plastic welding is extraordinarily annoying. When goo deposits are happening on a heated bed. That could be said of a hospital as well. Anyway, so this thing, in a nursing home, this is a disposable, fundamentally disposable pump, and it's not just because it's plastic welded together. A lot of companies love, hey, no screws, no fasteners, no clips. It's waterproof. Plastic welding is when you take two pieces of plastic, You put them together, and then you have like a plate that comes onto the back of it and shakes it via basically piezoelectrically, ultrasonically shakes it, right? And while it's shaking, it's rubbing together. And so all of the MERs of your polymer are starting to heat up and coalesce. And it creates pretty much just a solid weld where the two plastics come together. It's a little weaker than the plastic, which is why they have like a lip on this thing. But if you have to repair something that's plastic welded together, you're not getting it apart. Those polymers have gripped onto each other. Yeah, it's friction welding to plastic. It is welded. There's no getting it apart without significant damage. Now, you can take advantage of the fact that it is slightly weaker. It is slightly weaker than the plastic itself, and sometimes due to the fact that they have like a lip, because if they didn't have a lip on this, we could just flex the plastic and it would break along the seam. It would break along the seam because it's just a little bit weaker than the plastic itself. But they put a lip on it, and in doing so, that can sometimes help guide the braking on it. Now we had that little car starter that Groovy sent me, and that did not go back together nicely, just because it was also a plastic friction welded device. They're really annoying, these plastic friction welded devices. So the method for breaking them open is attack the corners. The corner is where you can get the most flexing, sort of, and it's where you can get sort of the dichotomy between the plastic bending and the plastic being rigid in order to get this thing to actually break open. So let's take, don't they have snacks for days in planes? Yeah, I mean, we weren't flying rich people plane. We were flying poor people plane, and I didn't know I was going to go low, so it just kind of came on very quickly. And we weren't on the plane, actually. We had eaten on the plane. That's when I gave the insulin. I didn't give enough, I guess, for the meal. Or no, I gave too much for the meal. Or it was bubbles in my reservoir expanding and contracting. So basically, by the time we got to customs, I was in a shit situation where we didn't have access to vending machines at all. Which is weird, because airports should be completely stocked full of those fucking things. But really, when you arrive and you get all the way to the luggage carousel, there's like nothing. So, how do you take apart a plastic welded device? Well, you answered the question by asking. You use a vise on the device. Did you guys get what I? Did you see what I? You guys get what I did there? Did you guys get the gist of that? I said the word vise, which is what we're using. I said the word vise, and that was part of the, yeah, you guys got it. So that didn't really work, and I'm starting to crush the circuit board. That flexed too much. So, try it at the seam. Flip it over. Do it this way. I want this to flex and crack and break. But I don't want to harm the stuff inside. You can see all that flexure happening there. This thing wasn't meant to get that kind of force on it. That's not right. The way that I wanted to do this, so my goal is to be able to program this NXP semiconductor device, right? I want to reprogram it. I want to fully reflash it and maybe use it as a development board, right? And that way I'd have this constant supply of dev boards. I just have to order the PCBs and transfer this stuff over to another board. I would love to be able to do that. I don't know. The only problem with that is that I don't have a lot of specifications. I don't have any specifications of this specific chip. So a lot of the registers and stuff would be completely foreign to me. It would just be an interesting challenge and a weird project to do. But my goal would be to be able to get into these faster and take them apart faster. But it doesn't look like, I mean, save for buying like a hot knife, maybe I could do a hot knife along that seam. The way that they did it for the research project, the PDF, the amazing job that they did hacking these things, they actually used a Dremel to open it up. So I think what I can do is I can crush this right on the seam, and that clear plastic bottom should probably give up. Let's just see if we can do it like this. This is going to fire off in a direction. I got to look out. Have you tried Critical Health News? They say you can cure diabetes in 3 to 12 months. That's fucking hilarious. That's so stupid. Yeah. I love all the threads about the cost of insulin, and people are like, Mark Cuban's pharmacy, and I'm like, that guy does not have insulin on there, and I don't think he will. I don't think he can negotiate insulin. It would be very nice if he could. Yeah, the plastic in a super hard device. That's what I'm trying to do. I heard a little cracking on that. I might have made a little headway. As soon as we get like something to bust open a little bit, I can get a pry bar in there. I don't want to damage this too much because I do want to show off the mechanism inside. I had really good luck with the wire cutter pliers, but we can also kind of force the issue here. And again, attack the corners. That's the strategy. You go for the corners. Because when you get your pry bar in there, the corners are the part that's going to support better, and it's going to allow you to pry it open a little bit more. So I opened up a little bit. Let's see if I can get a screwdriver and pick it apart without stabbing myself. That's usually, I've already done the stabbing for today. This is, by the way, this is where you try to force the screwdriver in, and it slips, and then you end up shrink, like just taking a chunk out of your finger. I know, because I've been there. The stabby, nobody really saw the stabby. I did a little bit of stabby to inject the pod, and then the pod did the stabby, but it keeps it under here, so you don't really see it. And I couldn't show that on camera because it's my midriff. I don't think I'm allowed to show my midriff on Twitch. This is going to fire out of here at 1,000 miles an hour, isn't it? Yeah, these are a little trouble to open up, aren't they? These are a little bit of trouble. Well, get more advanced things going on it. The other one that I took apart, that one over there, I managed to crack the bottom and then peel it off. So that's what I'm hoping to do here, but it's not capitulating. Would you just... This thing is really strong. Yeah. One more turn. Yeah. Man, come on. Look at that. Look at that. End mill the back edge. I mean, I don't want to pull cutting implements into this. I don't need to use power tools. I don't need to use power tools on this. Come on. Break apart. Do it. Yeah. Yeah. Wow, that's a fair bit of force for not breaking. Oh, the back part broke. Okay, good. All right, we got an in. We got our in. Sensual midriff, yeah. My belly. My belly. So I got a little bit of it to crack. Now I can get pry bars and stuff in there in order to... Basically, I just need to break the entire bottom part off. But I don't want to damage too much of the electronics. Unfortunately, that's just going to happen. Just a little turn of a screwdriver is enough. There we go. You see that? Now the plastic seam is starting to break with just a little bit of extra force. So this is an unfortunately violent part of this process, getting into this pump. You gotta be careful not to A, stab yourself with a screwdriver, or B, stab yourself with sharp plastic. So I usually roll the pliers, and that gives me a little bit of a pry, a little bit of a surface to pry, and that ends up giving me enough force to sort of start peeling the plastic. No, there's no clips. It's all plastic welded. This is an interesting product because it's made very cheaply, but also very well. Made well, made cheaply, and disposable. And it's a medical device, so obviously it's been sterilized and all that fun stuff. This is just an air hole, by the way. That's just to let air into the body. And the reason that it's back here is so that this thing can retain at least some waterproof. Some waterproofing. I don't know what happens when I go underwater with this thing. I think they're good for like a couple feet underwater, but I'm not sure how many. Certainly don't think that I can get scuba certified as a diabetic with a pump. I don't think there's a scuba diver's pump in existence. Why is my phone buzzing? Hold on. I need to get to the bottom of all the buzzes. Okay. Ugh, jeez, this thing is a pain in the ass. Pain in the ass. All right. So one of the features, 25 feet for 60 minutes. Wow, that's actually really impressive, to be honest. Here's the deal. This has a piece of memory. This has a memory wire in it. It's got this memory wire that's looped, right? And it's along the plastic under the circuit board there. I don't want to break that memory wire because I want to use it today. I want to take a look at the mechanism working. So I got to be really careful around this section right here, which is where my pliers currently are working. It's very difficult what I'm doing. Now, if I wanted to be totally non-invasive, I guess I could take a Dremel and go around the edge and slowly peel it apart. But I don't have time for that. Nobody has time for that. I don't have time for the thing that's going to work perfectly and be totally clean and easy. I guess I could run a saw on the end mill or on the milling machine and just graze the side, but I also don't want to do that. No, I'm just going to peel this one apart. Maybe we'll use power tools on another one if I end up ruining it. But I really want to show you guys all the mechanism inside of this thing because it's really interesting. Do I have any other tools that would benefit me doing this? I have all kinds of tools here. I just don't know which ones would be the most beneficial. I mean, maybe a saw blade? Nah. I don't want to make too much of a mess. I guess I'm going to end up making a big mess. I just don't want chips everywhere. I hate chips. Oh, looks like we paused. Print paused. Now I got to jam clear filament in there. Print pause. Okay. Get this thing out of the way. That filament goes back on the shelf. And then this one comes in. Bada bing. Bada bingus. And then I gotta squish a bunch of this stuff through until it runs clear. Ooh, luckily this hot nozzle in your area lets me squish quite a bit at a time, so I can fully flush out all of that stuff. Flush it all out, all of it. It's a big waste of plastic. Filament changes. And then I gotta peel that little bit of black filament that's stuck to the nozzle. I gotta get that away so it doesn't end up being deposited onto my print. Now this is not running it fully clear yet. I think I need to run more through, but I don't want it to pick up the off-color filament from the nozzle. So I gotta scrape it and stuff. There we go. Okay, so nice and clean there. And smash some more of this stuff through. Yeah, it's still coming in. It's like gray right now. I think what happened is it probably squished up along the side walls. There we go. Okay, cool. So now I can start this up again, and we're going to use the plugin that we installed from terminal. We go to the terminal, and I hit this resume button. And I hit that resume button. Press temperature messages. Changing monitoring state from pausing to paused. Resume. Huh? Wait, do I do at resume? Oh, maybe I need both of them in there. Oh, maybe I need both of them in there. I think I need resume and at resume. Hold on, wait, where are we? I already screwed it up. Oh, that's the wrong one. Settings. Extended commands. Resume. I think it needs to be resume and at resume. It didn't do anything. Wait, there it goes. Well, all right then. Is that at the right height? Yeah, it's at the right height. Okay, good. what that does is it prevents the printer from becoming confused when I resume, and that means that both Clipper and the G code are running now. Clipper would previously pause and not allow, it wouldn't resume properly, and it would be paused while G code was streaming back. So on the second filament change, it wouldn't stop. It would just continue to print because it was streaming G code and Clipper was still paused. So weird stuff, weird stuff. Hopefully it continues to do the thing. Okay, so we're having a little trouble getting into this pod. That's, I guess, partially by design, but it's the plastic is just kind of being unreasonable. This is kind of, I did this on my own, and I thought it would be a lot easier than this. I did this on my own. It was relatively simple for me to do, but I was doing something else at the time, so I wasn't really paying attention to what I was doing. I was just kind of like peeling the plastic. I mean, this method of grip and sort of twist to the side, especially with these, which have kind of like a wide area over here, that works really well for getting into stuff like this. But it is time consuming, and I just didn't want to use power tools. You know, sometimes you just don't want to use power tools. Could probably do with some power tool on this. We'll use power tools for the next one, I guess. Ow! Yeah, I'm harassing my dog because she's ripping stuff apart. And look what I'm doing. I'm not a good example. Don't end up like me, puppy. This is what the dog would do. What the dog doing? Okay, so maybe we do need a power tool on this. All right, I see how it is. I see how it is. Yeah, I put a bunch of big scratches into the circuit board when I was doing this. I guess I'll do it again. Yeah, that's putting pressure directly on the circuit board. I didn't want to do that. Yeah, all right. Let me go get the Dremel. Let me go get the Dremel. I guess we'll use a Dremel on this stupid thing. All right, let me go get it. I got two of them sitting on the shelf. Maybe we can find a Dremel bit that won't be so annoying. I don't want to breathe in disc dust, you know? I just don't like it. I just don't like it. All the disc dust. Where'd my Dremel box go? Oh, it's right over there. Okay. Maybe you can find a better tool for this. Well, one of the good ones is the plastic, knurled plastic post. That thing usually cuts through plastic like it's nothing. Like it's not even there. You can tell how much I use my Dremel because it looks totally, looks ancient. Man, I hate this thing. I really dislike the Dremel. It's mostly just because of the dust that gets produced by this thing. It produces just a ton of really obnoxious dust that is hard to deal with and annoying and blah, 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 blah. I could talk all day about it, and I have. So let me see here. I mean, some of these are just broken stuff. This would be the really good plastic bit. This thing eats plastic like... Actually, this isn't the good plastic bit. What happened to the good plastic bit? I had a bit that was basically just a post with a bunch of like sharp knurled diamonds on it or something. And that was really good at cutting plastic. I have this one, but this one is a spiral. So it's not that... It's not the one I'm looking for. I don't know what happened to that one. The home dentistry kit? Ugh. Ugh. Oh, thank you. I mean, there's this one, too. This one's like a mean... This one's like an arrowhead. How did I ever do with these? This would be good for engraving, actually. If I put that on an XY. Did a little engraving. Engraveling. If I'm going to be using this spiral post, I might as well use this other spiral post. Where is it? This one. This one will probably be a little bit more exact. Or I just use a cutoff wheel, but I don't want to breathe stone dust. Hold on, my phone is going nuts. Who is fucking talking to me? Spam. It's fucking political shit. Go away. Who is messaging me 1,000 times? It's like my phone buzzed at me 3 times, but there's no messages. I'm not popular enough. God. Like, do they even know who I am? Why are they trying to talk to me? I'm not popular. I'm not cool. Yeah, I don't want to breathe stone dust right now, so we're gonna try to work the edge with this little guy. I'll put it in, well, I don't need to put it in the vise, do I? Or what am I doing? I'm not even locking down the thing. Here we go. Yeah. I mean, I could also try diamond wheel. Diamond wheel might be a pretty good implement to use on the thing. I'm gonna get dust everywhere, which I don't look forward to. All right, let's see here. Plug it into the side of the desk, which is harder and harder to get to these days. There we go. The sound of a drill. Let's go. So, let's see here. I guess what I'll do is just plomp this guy like this. Give myself a little bit of room. I'll just work out that edge. Is that gonna work, or should I go above that? Nah, we'll do this. I mean, this thing is just melting the plastic. This is what I hate. Reverse friction welding. Yeah, exactly. I hate all this fucking crap that it creates. Look at that. I had a perfectly clean bench before I started doing that, and now it's covered in bits of plastic. I hate it. I hate it. I hate it. I hate it. Yeah, the only problem with that bit is that it skips around. It creates a very fine particle, but it also, and then the bit gets super hot and then starts melting the plastic. But Dremels can be pretty effective at getting rid of plastic with the right bits. It also really destroyed this, huh? All right, so I didn't quite get in all the spots, but I did persuade it to give up. This is where I get a massive cut on my hand. Insulet Corporation does not condone any of the activities that we were doing today, by the way. Let's just let that be known. That's going to be a problem. See, the all the stuff that's in this will just come out. It'll just fall out. So this should separate, but I need to get a little bit of the stuff removed before it will fully separate. Come on, buddy. Give me that insulin pump. Insulin, you should have seen the other guy. What is still holding you in? I wonder what that little piece is right there. That's an interesting little thing. Okay, hold on. Just gotta get to the other side of the board and convince it I would like to remove it from its shell. It's like a turtle. You just have to harass it enough, and it'll come out. You'll say, "What are you doing?" And you go, "Shut up, turtle. I'm in control." Ow. Come on, get out of there. Because the edges are so rough from the Dremel, it's like gripping this thing in a weird way. There we go. All right, so the tube, I mean, we just have to get the tube out of there. We'll just know that there's a tube. I'm gonna stab myself by accident. Oh boy, I gotta be careful because this is a sharp needle. So that goes like right there. Okay. Omnipod dash. Let's take a look. Let me clean the desk off too. So we get our first impression of the mechanism of the Omnipod dash. And we haven't seen all that there is to see yet. There's quite a bit to this little guy. And if I accidentally touch the batteries, this thing's going to start screaming at me. I don't know what the protocol is for it to shut down, but if you remove power and then add power again, it'll boot up and then start screaming that the insulin just isn't there. This is the Omnipod Dash. This is kind of an interesting little insulin pump. It's an all-in-one. Everything is on this little device right here, and it's all being connected via springs. Springs are what's bringing the power to all the bits and bobs on this board. So these two contacts right here, those are actually for the piezoelectric buzzer, what resides on the outside shell in order to give you maximum screams per volts. I hate piezoelectric buzzers. All right, I need to move myself so that I can sit under the microscope a little bit more. I'm gonna move my light over here, like that. Position myself, and then I need to move my window over. Is the print paused? No, it's not. Print is still going. There's a couple layers. I mean, it's like 2 millimeters worth of plastic to cover. All right, so insulin pump. How does this thing work? Okay, it's a whole thing behind the mechanism here. Now you can see that there is the pink bar right there captures the tube that goes under the skin. The needle is always present. There's always a needle present, and it's just above the surface there. So that last little bit is what goes into the body. The needle is what carries the insulin no matter what. So this, and the reason that I'm emphasizing that is that normally you are not left with a needle. Normally you retract the needle entirely and then clip on the thing that's delivering the insulin. So you would have an adhesive patch that has like an auto injector that would do the spring work mechanism here of injecting with the tube around the needle and then retracting the needle fully. And then you would be able to add the thing that puts the insulin in. In the case of the Omnipod, the needle stays in that tube because it's the tube that's carrying the insulin in. So here's the plunger. This thing is retracted all the way back. Or no, yeah, it should be all the way back, right? No, it's all the way forward. Yeah, right. Sorry. The plunger's all the way forward because it's delivered all of the insulin. So this is delivered all of the insulin. The plunger's all the way forward. These two contacts are exposed, but all of that insulin goes out, around, and then in. Because this also, remember, has to retract. It also has to, it needs to move. This needs to move. So this is actually kind of a spring that they've engineered into the tube. Each individual piece of this is actually kind of an interesting study in engineering. It's all made to be as cheap as possible, but also to be as effective as possible because you don't want these things failing. Now, this little spring clip right here, literally just a piece of metal that's been plastic welded down. Why does that look so sloppy? It looks so sloppy. Anyway, we can remove that limitation. I don't have such weaknesses, right? Can we, hey, hello? Can you just, why is this thing so, man, this thing is really on there. So yeah, that is typically when in storage, this thing is retracted like this. And yeah, see that busted through the sidewall of the tube. but the tube is right behind the syringe itself. So when this thing goes off, this arm extends it out this way, that injects, and then when it pulls back the syringe. So while in storage, this arm is actually spring-loaded. It's over here. And I would like to do that. I would like to spring-load this thing and see if we can make it do an injection cycle. That's going to be tough to do. These things are very hard to work with. There's a lot of one-way streets on this thing. For instance, this rod right here is captured by a spring that then couples it to this gear wheel, basically. And as that gear wheel rotates, it will expose a flat section to this little pawl, P-A-W-L, that is currently pressed. Well, okay, so it's currently pressed down, and so that little catch right there is holding this entire mechanism back on the giant spring. When the flat spot goes a certain distance, it will release this, which will then inject and retract. And they're all doing that with the circular movement of a massive spring. This is a big spring. Look at that motherfucker. Look at that thing. Big spring. So it's all moved by this wheel. And this wheel, of course, has contacts on the front so that it can be electrically monitored to make sure that it is turning. But bother, how does that wheel turn? Is there a spring inside of it? No. This moves via memory wire. So let's get the circuit board off of here so we can take a look at everything, and I can inject voltage into it, and it can not scream at me for being out of batteries, because it'll try to... Well, actually, we don't have the buzzer on there. So these are all plastic welded tabs, right? Only one solution for that. I guess there's probably multiple solutions. I could probably get a drill bit on it too, but I mean, this will work too. And we don't care about the integrity of the circuit board. I've already bent it over here. So all I need to do is just get under them and just pop off the mushroom cap. That one really didn't work out too well. It kind of made me into a liar. Don't make me into a liar. Both the instrument and the type of thing. Anyway. I gotta not cut towards my freaking hand. All the good ideas today of just cutting towards yourself and, cut towards your friend. Don't worry. Hands grow back, sort of. Remember, you're the most fragile thing in the shop, and you're also the only thing that can heal. So really just put yourself between the workpiece and the machine. The machine can't heal. You can. All right, so as I pry this thing apart, all kinds of springs fall out. Just all manner of spring. Just fall, little rods that are sprung. What is that one to? Wait, this one's interesting. This one is like part rod, part spring. What the heck? Look at this. Wait, what is this thing? Hold on. I'm shocked at the level of engineering. Look at that. Hold on. Where's the microscope? It's right there. Look at that. I guess that's just a spring contact, huh? Weird. Everything in this thing is springs. It's all springs. I always break this part right here. So yeah, this would be the the machine can't heal, but the replacement parts don't come with phantom pain. Yeah, no. It's I don't know why anybody would ever listen to anything that I say. This is the NXP semiconductor. It was originally a Freescale semi device, but NXP semiconductor, custom-made microcontroller. I didn't look this up, but I'm guessing this is just an NXP EEPROM. I don't know why they don't have an internal EEPROM that's capable of handling the storage that they need, but I mean, clearly I2C, because 2 wires going from chip to chip. I don't know what this thing would be doing. I thought this thing would be RF, but RF is going directly. I mean, this is a freaking antenna right here. So this thing is handling the Bluetooth low energy out of 1 pin. It's got a clock, and then everything else has probably toroid. Actually, those look like caps. Are they caps to ground? That's weird. Yeah, and we just got like a bunch of capacitors on here in order to sort of suppress transients and stuff. But like, I don't know why they wouldn't just... Why not just have enough memory on this thing? Then you'd have 1 chip. Why 2? It's super weird. Maybe these fail at a different rate or something like that. Very strange. But anyway, yeah, as simple as possible, 4-layer PCB, internal, I want to say it's an F antenna. I think it's an F antenna. It's just kind of weird looking. And then, yeah, 4 layers. The reason we know it's 4 layers is because we've got vias that have halos around them, and that is indicative of a multi-layer board. So what this one is doing is it's not bringing current to the ground plane, it's bringing current to somewhere else. It's bringing a trace wire to some other internal layer that shouldn't connect to ground. So when you see these little vias that don't go anywhere, especially not to ground, you know that it is a multi-layer circuit board. So it'd be taking it all the way up to the top, or maybe both to an internal layer. And that way what they can do, it's actually weird. It might be multiple layers on one side and not the other. I don't know. Because this is weird, because like, they're doing a lot of stuff on the top layer here. It's kind of strange. Huh. Well, anyway, multi-layer board. Very thin board. I would guess that they're getting them by the bushel, so they're getting a good deal on, you know, getting 10,000 boards. They certainly get a lot of money for these things compared to what they spend making them. They're not in it out of the goodness of their hearts, that's for sure. But anyway, the cool stuff, the really cool stuff, is with this, which is all of the mechanisms that exist inside of the Omnipod. Now, what I'd like to do is to get this memory wire working. Check this out. So they decided, and this is one of the few applications of memory wire in the real world. The only other applications that I've heard of, and I haven't heard of many, are like there's like a particular memory wire thing that functions on the I think Curiosity, or is it the other one? I don't know. It's one of them space proby thingies that are all alone on another planet. But anyway, this right here is what drives the mechanism. Basically, this piece pivots back and forth, and it makes an electrical connection to either of these posts. So as the memory wire is activated, this thing tilts and pushes the gear forward with these two little PAWLs, these little pawls. Actually, that might be the wrong word. I might have used the wrong word. But as it tensions and untensions, this thing is driven forward without the aid of a spring, which is kind of an interesting feature of this whole thing. There's no spring in here. It's just a piece of memory wire that moves back and forth. Let's try to activate it. I think it's 4.5 volts does this thing. What is my power supply has been on all night? I forgot to turn it off. Hold on, let's get to it. Let's get to this view. Okay, I need 4.5 volts to simulate all of the batteries functioning at once. Move that over a little bit so I can get my arm down there. Volts. 2 volts. 3. 7, 8, 9. 3 volts. 4 volts. I'll give it 4.48. That's close enough. How's the 3D print doing? It's still printing. I know, isn't that weird? It's a very weird mechanism. This thing is still printing. Okay, yeah, it's still... It might be the last layer. I don't know. Isn't that weird? I thought... So my understanding of how this thing worked was wrong. I thought that they had a coiled spring that was able to mechanically, like... You know, I thought it was a coiled spring that was held back by a mechanism, and then that mechanism would release it for each individual click that it makes, because it makes a clicking noise when it's delivering stuff. So I thought that the clicks were because that spring was hitting up against a stopper, right? That's not at all how it works. It's kind of, oh God. As I moved my arm, this spring right here, this little battery spring, rolled across the bench. It rolled across the bench like this, and I thought it was a fucking spider, and I had a heart attack. all these springs, man. These guys must have it good with a spring manufacturer. They must know somebody at Spring headquarters. Spring here. Who you calling? We want like 10 million springs. Yeah, we got 10 million springs. We can deliver those to you. Why doesn't that one have a thing? Coils are us. Yeah, we got coils. Spoopy season. Yes, I got spoopy seasoned. What is this? Oh, I see. Maybe it just fell out. I was wondering what the other battery did. Because there's 3 batteries, and I know there's 2 voltages that run around this thing. Okay, so we're just going to do 4.5 volts on this and see what happens. Where's my leads are buried. I buried the lead. Here, I need to put this into something more solid. This needs to be in a vise so that I can hold it still and manipulate it. Because we're going to be tensioning springs and stuff in a minute. The tensioning springs with syringes on the end of them? Sounds like a party. Okay, here we are. Omnipod. Omnipod! What are you doing, Omnipod? Okay, so 4.5 volts might burn up the memory wire. I don't know what voltage this thing operates off of, but I do know that it had like a whole transistor on it before. But let's just see what happens. You and you. Well, that tensioned it. It pulled it downwards, which is a little odd. Huh. Try the other polarity. I don't think it does anything different. Maybe it is tensioning a spring against something. Because that didn't move it at all. I thought it was a back and forth movement, but this thing appears to be like releasing. Or maybe I just need tension down here. I need tension on the top of it in order for it to properly move back and forth. Seems a little strange to me. Is it registering as a short in the power supply? 0.18 amps is going through this thing. Yeah, it doesn't appear to be moving in the way that I thought it would be. But there isn't like a master spring in this thing. You can see that as it turns, this is moving with it. That spring just gets released in order to capture the plunger shaft. What I really need to be is moving it towards me. Hold on. Springs and spiders, yeah. That's their grand scheme. Springs and spiders, my man. That's what it's all about in the end. I don't want to break it, but because I really want to reveal how the mechanism works, but I also want to release the tension so that I can wind back the plunger a bit into normal operation mode. So it looks like I am going to have to peel this thing up. But I thought it went back and forth like this, and that was the whole point of these contacts. Like, if I hold this, but then I power this, it just moves up a little bit. It seems like it's like releasing. As you can see, tension, release, tension, release. What if, oh, maybe... Ah. Aha. Yep, there it is. That's what it is. So let's try it. Let me try to get a little bit of pressure off of this thing, and then I can operate the mechanism. So it uses the memory wire for 2 movements. So what I need to do is release those 2 little things at once so that I can rewind the mechanism. Clever, clever. I'll explain in a minute if that escaped you and you didn't see what happened. Figured out how this thing works. This thing really doesn't like moving in the direction that it's not intended to move in. Oh, damn it. It's because I'm breaking it. Ugh. Shit. I'm breaking it. Ugh. Breaking it even more. Yeah, see, it's catching the gears, and I want it to release them. Do 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 do. So as I rewind this, a little piston comes out of the side here. I guess you can't really see that as well, but there's a little piston. It's just a metal rod that goes all the way to the plunger. So when this thing gets to a certain amount of insulin, contact is broken between these two springs. And so the microcontroller will know that there's a fixed amount of insulin left. And that's also part of what makes it beep, is when this gets pushed back and that thing makes contact, there's a certain amount of insulin inside of this thing. But the mechanism itself, the way that this thing moves that gearwork forward, is by one piece of memory wire that makes two different circuits. So when you energize the back and forth piece to ground, and you hit either one of these contacts with power, part of the memory wire is going to go back into its original shape. And when it does, it'll create tension around the pulley and to one side or the other of this piece. So that piece just goes back and forth. That's all it needs to do. Let me get, what if I do this? And then I can just hit one of these. Oh, nope, that broke off. Try to use my scalpel as a metal contact. Totally metal contact, bro. And that's what moves the gear forward by pushing each side. Now, this is bent out of shape, so it's not quite contacting the way that I want it to. But the memory wire is able to move it to one end. Hello? Or the other end. And then it hits up against this contact here. Yeah, it's trying to push from there, but it's having trouble because it's bent. It's interesting. I don't know how much force the memory wire is able to actually exert upon this thing. But I guess if you just walk it bit by bit... Yeah, see, I've already ruined it. It doesn't really work anymore. Just because it's having trouble actually pushing because of the contact is bent. It's probably off of the pivot too, yeah. It's all effed up. It's all effed up. Yeah, see, I wanted to move this way, but I think this one is the one that's having trouble pushing forward. I don't know what makes the clicking noise then. There's like a little snapping clicking noise that it makes when it goes back and forth. What's this song? What? Yeah, isn't that clever? It's a really strange way to use memory wire, but by God, they did it. See that? Tensions. And that tensions. And it moves it back. Back and forth like so. And it pushes this along. It doesn't appear to be like tensioning as hard as I'd want it to. I think maybe the power supply might be putting it into putting us into a mode like a short circuit mode. I think that may be what's happening, and I'm not able to get full current on it. Yeah, I hear the power supply ramping up. It's putting 0.3 amps into the thing. What does it look like on the thermals? Oh yeah, it's pretty warm. There's a little bit of heat in there, huh? Maybe you should let it cool down a bit. Where's my focus button? There. The Brio can get pretty close. It's a pretty decent macro. I'm gonna let that cool off a little bit. I guess there's a little bit of heat in there. Yeah, avoiding motors and gears, making it smaller, making the mechanism only do one thing, lowering the complexity significantly from what a motor would be. I mean, the insulin pumps that we've taken apart, the T-Slim uses a Swiss-made like gear motor, but that thing, I mean, that of course the Swiss-made gear motor has to function for an extended amount of time, whereas this only should last a couple days any longer, and it's not supposed to. So look at the heat going into the memory wire there. And as soon as it cools down, it slacks. Sort of. I wonder how strong that is, though. How much force can that thing be putting into it? I mean, it's kind of broken right now because I've bent these little arms. Little arms are supposed to be, I mean, if you support this thing properly, those little arms are supposed to be able to move the gears. And I guess they can. Back and forth. They make a clicking noise. But I don't have any of that support in place, so when it tries to push, it gets stuck. Clever, clever, clever. I did not know that because I had originally thought that this was a wire that was holding back a spring, and so somehow the memory wire retracting would be capable of releasing the spring, but instead it is being relied upon. Oh, I guess you got to wait until it cools off. So now it needs to cool off. If I blow on it, it should be a little faster. Now it should be slacked, and I can activate the other side. Now, well, that one's having trouble. But if I immediately go to this side, then it'll... Oh, that still works. Works against itself a little bit. You plug this into a hose in you, and it runs through the day. No, 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 no. No, 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 no. Not quite. And you're close. This plunger moves insulin into this wire, which is actually a syringe. Let me get my knife. My pointing knife. I need my pointing knife. This plunger pushes into this hollow wire syringe that goes into a tube and stops here. And then that tube goes under the body, just into the skin, where the insulin is deposited. Now, this gnarly mechanism right here is what is responsible for pushing that needle forward into the body and then retracting it and leaving behind a tube. So if we can get that running, it'll be pretty interesting. So what I need is for this to be over here. And I can't show you guys this part without taking it apart. So we'll try to get this part working first. The part that captures the plunger is fairly interesting, but for now, I just need this to hold on to this thing. Oh, I overdid it. Okay. Well, I guess I can go 180. Yoink. Little clockwork mechanism thing. So, if I can get this to hold tension without it slipping... Oh, I see. This is in the way. So the tube thing has to be out of the way. The only problem is, in order to load this up, I think I need to tension that spring and somehow hold it in place, which is nigh on impossible to do without blowing up the whole shop. Isn't that cool, though? All the mechanisms in this thing. See that little lever right there? There's a little ramp right here, and that little ramp pushes up this piece of copper. I don't know why it's copper. I guess, I don't know. I don't know why it's copper. Maybe there's an electrical connection between some of these parts that it senses whether or not this thing is loaded. Because I basically need to hold this up so that it holds this back. And it has to be the whole thing. Yeah, I think this thing is... I think it's like one of the cooler things that I've taken apart in recent memory. To be honest. TBH. Why am I doing this with a knife? I'm poking a knife into my finger. What am I thinking? I've got enough knives sitting on the front of this fucking thing. All right, so this I need to move 180 degrees around, and I don't have a tool for that. Yeah, non-toxic, doesn't rust, etc., etc., and I guess makes a good electrical connection, but it's just strange to me that it's all up in here. I really want to get this mechanism loaded up, and I think probably the reason for this hole right here is that you would clip something to hold this in here, and then you could load the mechanism. That's my theory anyway, but I don't have a thing that I can put here that'll hold all that tension. Got all these LEDs all over the shop. I'm gonna move them somewhere. All you electronics, get out of my way. And this fucking knife I gotta put somewhere else too. I need a big thing, because this is a big spring. This is a huge frickin' spring on this thing. Look at this. Look at that thing. It's huge. It's like the most dense. Scares the shit out of me. Let's see. I think what I can do is use my ring puller to go boop boop on these holes, and then I can twist that around. It's going to recapture this when I tension it. And then the flat spot is right here. It's not ready to go. Yeah, it is. Flat spot's ready to go. Actually, I can push that down now. And that pushes up this, which keeps this taut. No, I need it to slide around as I move this, so... Oh, God, this whole thing. Let's see if I can tension this thing without sending a wrench into my face. Actually, this thing should be pausing soon, I think. I could have done thinner plastic on the illuminated things, but I wanted it to diffuse light properly, so there's going to be a big layer of this that's plastic, that's clear plastic. Yeah, see, it's still laying down that material, but it should be done any second now. And then I'll do the filament change. Hopefully we'll get good results with my fancy schmancy resume button. All right, let me get my tool, my weird tool. I think it's down here. Yeah, there it is. I think I can use this, and I think I want to use the right angle one. The 45-degree angle one. What's this one? That's a different one. Okay, yeah. Probably this tool here. This thing. The ring pulling tool. Because I can use that as a lever arm to put tension on this thing and hold it. But I do want to do the filament change before I end up doing this little piece of acrobatics. Because, yeah, this thing is like the most interesting part about this pump. People are missing out. People are missing out. All those viewers that aren't here right now. How do you hold them if they're like this? I guess maybe you put something on this, like that. How do you do that? Oh, I see. There's two rubber... No, those aren't rubber. That's riveted in. Huh. Weird. Weird. So what mode do I want this to be in? I guess it doesn't really matter. Oh, I see. That's how you do it. You do it down there. Oh, I get it. I get it now. Yeah, I saw it. I saw it. I saw it. I seen it. Jeez, when is this thing going to be done? I'm waiting for the printer to pause because I've got a routine programmed in there. All right. So because these are little brass plates, the one that I was testing with, I completely ruined. Yeah, see, it needs to go all the way out. And then I think... Yeah, see there, it just undid itself. Gotta be careful because there's a freaking syringe on the end of this thing. Boy, is my field of view that narrow? What's going on here? Like, always out of focus. Sounds like a personal problem. Ugh. Right from this end. Don't get your hands anywhere near any of this stuff. Uh-oh, slipping on the vise. Please don't. Please. Push this down. Shit, I missed it. It's slipping. Please, please, please hold on. Oh. Please hold on. Shit. Missed it again. I don't know how many rotations I have left in this. Okay. Careful. Shit. Huh. Slipped. It keeps slipping. It's tripping. Why isn't that holding it down? What's your problem? Why are you doing this to me? Specifically to me, not anyone else. All right, I think that's tensioned. So I'm going to release it carefully. It relies on the top of everything to hold it down into that catch. So when I let go of this, it's just going to inject. So let's try to get that on camera. So when this little lever here is released, that lets go of this whole mechanism. I need to release it right now just manually because it's not functioning properly. It needs the top of the pod to hold it all together. So when this thing rotates out of the way, a little flat spot is it basically opens up, and then this little lever goes all the way up. That releases tension here, and then this thing is allowed to rotate. Jesus Christ. It rotates with a lot of force in order to move this forward and then backwards. And when it moves it forwards and backwards, the tube gets caught on this thing. Yeah, it is like it's like a tiny little mouse trap that just wants to harm me. So I can't seem to get it to capture. Oh, looks like our print is paused. Hold on, I need to go do this. Perfect. And now I'm horrified. I'm glad to have horrified mega science. It is like a little horror movie trap. But like that's one of the things about the pump that makes it completely unreusable. One of the things, and we'll look at the other one in just a second here. I just need to get the filament sorted out and extruding properly. You know, I guess I don't really need to prime this because it'll just do its thing. Am I losing temperature? No, there we go. Because this will just continue to print and then it'll eventually run black. But I'll be a proper 3D printer and actually prime the nozzle properly. It takes a lot of plastic to switch from clear to black and back because you've got to push the entirety of the material out before you get the proper color. Otherwise you get this weird gray. Yeah, that looks pretty opaque. All right, that's ready to go. So now we use our fancy schmancy resume button. that has both resume and at resume on it. Theoretically, we're back in printing at the right height. Right into the next layer, which is putting down some borders. Beautiful. There's a little bit of a string there. Ooh, that's not good. That's a bit of a string. Hopefully that comes off eventually and doesn't totally fuck over my print. Don't fuck me, printer. I got my eye on you. All right, back to spring-loaded injection mechanisms. So yeah, this is it's like a puzzle made of giant springs and needles. What more could you ask for? So this little guy here, all it does is rotate, and by rotating, this thing not only primes the pump, it advances it advances the plunger, releases the injection, tells what the position is, and captures the plunger initially. Certified to pierce dragon hide. I guess for people with like metal skin, they need to have a big spring on this thing, I suppose. I want to see if I can get this to actually hold it back. It's weird that it didn't. I wonder if maybe this sits here and this is the piece that holds this back. I don't know if that really makes much sense. Because it wasn't able to hold both of these back. So let's try, I'm going to try tensioning it again. Man, I can't talk today. Fucking, one would think that, you know, this is what I do, and talk all day, I would be a little better at it. Shit. Now, I would really love to be able to hold on to this thing better. I don't know where to clamp it, though. That'll actually hold on to it really well. I'll just give it a lot of tension, but then the whole thing starts to bend. And that's what was killing us before, is that the top part of the pump, which has little features in it to hold down stuff and keep it in place. We don't have that. I think there's a piece that clips on that. Yeah, weird. How do they put these together in the factory, I wonder? I gotta be careful not to rest my hand on the right side of this thing, because there's a freaking needle right there. You got a freaking needle on me. Yeah, see, that simply does not hold back the mechanism unless it's all together. So this, I gotta work backwards. We can just, well, I want to see that, I want this whole thing to operate. That's the problem. I can move it with my hand, but I don't want to get my hand anywhere near this fucking syringe that's just sitting at the end of this thing. Spring-loaded death mechanism. I used to play bass for spring-loaded death mechanism. They kind of sold out, though. So if this sits here, maybe this will capture better. Or at all? No, that doesn't work. Aha! Ah, damn it. I didn't quite get it. Now I need to rewind this because the plunger's all the way at its max, so I need to pop up the lever mechanism over here. Shame we can't see this whole thing working at once. I could click the memory wire and have it do its thing. Let's see, righty-tighty, lefty-loosey. I think I need to move in this direction. No, this is the direction that it moves in. It needs to go this way. Did they really reverse thread this thing? Rewinding the pump, rewinding the pump, rewinding the pump. You can see at the head of this thing the mechanism that actually captures the plunger. It captures the brass rod that will advance and retract the plunger. That's what we'll look at in a minute here. It's a really cool mechanism. All right, that gives me a bunch of rotations of this thing so we can properly play with the spring-loaded death trap that is the other side of this. All right. These are all bent out of shape now. This whole mechanism is just fucked. Oh well. So if that's moving this thing, this thing pushes it that way, so it moves this way. So actually, this would move out of the way by fully... It actually pushes this thing downwards in order to release it. Because, yeah, it's captured going backwards, so it moves this way. And then let's retension before I do that. Ugh, this thing is... It rightfully so, it makes me nervous, you know? It has every fucking right to make me nervous. So we can do this while there's no tension on it. And that goes right in front of the little tongue or whatever. And then this pivots and pushes up this piece with like a ramp. I could get the metal out of here. We could do it without the metal, but I'm streaming, so I'm doing it with the metal in place because it's more funner. Risk is fun. So this, where's my flat spot? Okay, my flat spots are there. It's ready to go. So now I just need to wind the enormous spring with the spring winding tool. Not really meant for this job, but it does it. That goes all the way up and back. And then while under tension, I have to do this. I guess I do have to do it while it's under tension, which could easily send a syringe into my hand. Not that I haven't done that before. Don't think that's a rare occurrence around here. All kinds of interesting injuries. So like somewhere around, oh, no, don't slip out. How do I move that and that at the same time? It doesn't want to move that lever all the way down. How does it even manage that? Does it go downward or does it go... I mean, this thing only moves in one direction. That thing goes back and forth, and it moves that this way, so this goes this way, and then it would be pushing this thing downwards. I've been described as a tiny piston under tension. Yeah, tool abuse. Well, I mean, yeah, it is tool abuse. I'm not squeaky clean. If I could just get this out of here. Okay, there. We did it. So this is now loaded and ready to inject and then retract the syringe. Let me just do a little piece of little scissors action and just expose the needle. Because the tube was blocking the scary syringe end. There it is. That is a sharp, well, semi-sharp syringe. It's already injected into me, which means that the tip is just a little bit dull. We could probably put all of the spacers on the microscope and actually get this thing to, we could look at it under the microscope, but pretty damn close. I mean, we've gotten close enough to see like silicon chips and stuff really up close and personal, but I would have to get the Z-axis over here, my Z plate. I don't want to do that right now. So anyway, this is locked and loaded. So this is what happens when you first, and I can't show this part of it. This would be another spring mechanism that I would have to load. there is a coil spring in this part of this gear. Oh, there, I tapped it hard enough and I barely even touched it, and that was enough to set this thing off. All right, so you just saw the draw and inject scheme. So this thing at like lightning pace goes 180 degrees, and when it does that, this arm is pushed all the way forward to inject both the tube and the syringe. The syringe, of course, leading the tube so that everything goes in nice and smooth. So everything goes in. This thing goes all the way out to its furthest extension at, you know, whatever, 90 degrees. Then this plate right here springs down off of the ramp that this thing has. So it's a very gradual ramp so that this thing isn't preventing the movement of the mechanism. Now, this is a very small spring compared to that thing. It's kind of crazy. But anyway, once this thing gets to a certain distance, aka full extension, this, you see the cutout right here for that plate. That plate drops and it holds the tube out. This thing isn't done yet. It keeps rotating all the way around to where it is right now, and that retracts the syringe and leaves the soft tubing behind. I would allow this thing to just keep the syringe in my body. I don't. The infusion set that I used to use had just a stainless steel syringe at 90 degrees, and this thing can occlude. The pump, the tube at the end of the syringe here, this thing can just bend and clog. I don't really think there's anything in this to detect when you have an occlusion, interestingly enough. The other insulin pumps will have like the ability to detect tension on the device. See, these two contacts right here are connected to this rod, and that rod is just an electrical contact. It follows the piston as it moves forwards, and once it breaks contact, the pump knows that there's only a certain amount of insulin left, or that a certain amount of insulin has filled, and this thing is able to then operate. So there's all kinds of clever stuff like that contained within here. Chief among them is the capture method for this plunger. When you inject insulin into this, there's no way that you're going to be fighting a threaded rod, right? So what you do is you have a brass rod around your threaded rod, and the brass rod is threaded. So this rod spins, the piston spins, but when you first inject insulin into it, the rod simply moves with the piston and goes inside of this spring mechanism. In order to capture it, you move the spring mechanism a certain amount, and then this spring right here ends up in a cutout on this backing to the plunger. When it reaches that cutout, it releases part of a coil spring that will then capture the brass rod. It's insane. It's extremely clever. I'll show you guys. Let's get this thing apart. I guess it's as simple as just like bada bing. Oop. Bada bing. Bada bing. Bada bing. There we go. It's one of them. I don't have like saline solution to show you guys the full operation of this. If I was making a YouTube video, I guess I would get like just some water in a syringe and just inject it and show the entirety of this thing functioning. Very clever mechanism. All right, let's get this out of here. Come with me. Oh yeah, let's get the syringe out too. Just unhook that. So once you do the initial fill, if you were to try to inject insulin into this thing, it would just end up pushing it out of the syringe. So there's all these one-way mechanisms on it. Chief among them is the injector, but then this method of moving a plunger is also one direction. It does not, you cannot reverse it without doing what we're doing and taking the whole thing apart, which is really unfortunate. It'd be nice if there was a way to re-up the reservoir on this at least once, but there just isn't. So what's happening here is we have this spring holding on to a brass rod. Here, let's go over to this. So many terrible ideas for fluid to put into that. There was somebody on, somebody who watched this channel a long time ago who was on, he had an insulin pump, but it was a pain pump. It was actually supposed to inject, it's supposed to. it would inject painkillers. So you see that? This spring is tensioning against the brass rod, and the brass rod pushes the plunger forward with its threads. And that's insulin right there. That's insulin. And there's an odd cutout right there. And that cutout, where did my brass rod go? That cutout is designed to allow this piece of metal to let go of a spring. The spring actually moves it up and out of the way, but that metal plate holds this down until this rotates a certain amount, and then it will release the spring. Hold on, let me see if I can show that. Probably can show that. I don't know. I haven't had good luck reversing this thing. It's so annoying how much of this design, how clever this design is, and how one way it is. There's just no getting back any supplies. So there's a little cutout at the top of the spring. Little cutout. Sorry, a little cutout at the top of the cog wheel. And that goes in like that. And then you wind it in the untensioned direction until it goes into that clip. I can't do it with these tools. I cannot do it with these tools. What do I have that could possibly do? The wire wrap tool? No, I think, oh, this one. There we go. Pin gauge. Actually, that won't work either. Yeah, it's not going to do it. Because I need to get it into this, put a fingernail under that, and then I need to somehow wind this all the way back to here. Ow. Owie. Thinking. What can I use? I mean, basically what I need is like something like this, but thin. Just like a rod with a hole in it that can hold on to the end of the spring and allow me to manipulate it. Manipulate it all the way into position. Like a piece of circuit board? No. Let's see, what do we have in the pencil bin? Not really anything. We have weird specialty tools that aren't meant for this sort of thing. Probably. Where would they be? Where would they be at? What is that? No, that's like that's for something else. Now, how about down here? Something that was meant for a completely different application. They always are. Wow, this would be such a good tool to do one thing with, and you end up doing something completely different. And it's practically like the syringe would practically be a good tool to use. That's a piece of, no, that's not what I'm looking for. Nope, nothing in there. I have a family member here, and they insist on turning up the heat. So I have a fan on me, and I'm sweating, and the window's wide open. Oh, okay. I'm gonna try to see if I can get this thing to load up, just so you know how it works. But I don't think I'm gonna have good luck with it. So anyway, what is supposed to happen is this spring is held down by this little nub, and it's held in an untensioned position, so that once you inject insulin into the reservoir, this rod simply falls down into it, and then it's released, and it grips that rod. And then from there, it gets twisted. So it gets twisted, and I think it gets twisted in the tensioning direction, so in this direction. And so that just simply rotates the rod. And so what that means is that if you don't inject a full reservoir, it can still move this thing properly. And there's no like mechanical, basically the plunger can move freely until this thing starts capturing it. But it is, again, another one-way mechanism. I'm having trouble rearming this stuff. That's difficult to do. And also, this will immediately release that spring unless it's held back by the plate. So when it goes a certain distance, this little nub will fall into that cutout, and it clicks the spring onto the rod. Just who's making these things? Like, geez, that's crazy. I guess there's a little tension spring on that too. I do kind of want to, I want to arm this thing and use it, show it in use. I got insulin all over myself. This stuff is expensive. Isn't that weird? It's like totally clever. It's really, really clever, and it's almost like completely and utterly engineered to be unreusable. In like a regular insulin pump, you would have the motor have a different mode. Get it? Motor? Anyway, the motor would have a different mode, and that would allow for the retraction of the plunger. But this doesn't have that. It doesn't have a motor. It doesn't have anything you can operate like that. So rearming this would be a matter of untensioning the spinny part somehow. You would have to, like, I don't know, what would you even do? You'd have to like drill a hole and get your tools in there just right. Because, like, I mean, you know, you can leave. I've done cannulas for longer than 3 days. It's not a game breaker, right? It's not a deal breaker. Game breaker. It's not a deal breaker. But it gets a little less safe when you use it for that long. I've heard of people reusing supplies for extremely extended amounts of time. How would you be able to do that, though? How would you be able to redo? Because you have a threaded rod. It's a very simple threaded rod that's advancing your plunger. You would have to turn that into a different method. I'm going to put this back a little bit so that I can grab the plunger and sort of set it backwards. Problem is I need to hold tension here. Yeah, this is like impossible to reset effectively. I think I did it with my fingers, but my hands are like filthy. So I can pop this up. Move this back over in this direction. Just on my nail. Ah! I don't think I can do it. I don't think I could do it. I need like a tool that I could put in there and twist, which I kind of have. Ah, bastard. Thing's a bastard. Nope. Yeah, I need like a special tool to do it. And yet here I am, insistent on, ow, doing it with my hands. It can't be helped. Yeah, displaying this action all at once is like goddamn impossible. I mean, I've got boxes and boxes of these things, and they're all just sitting there under terrible tension. There's all these loaded springwork mechanisms in the thing that are designed to explode on command. Like, how do they come up with this? What were the decisions behind it? Why not put just a cheap little motor in this thing? They were insistent on using memory wire, I guess. What is the reliability of memory wire? I mean, I guess one of the Mars rovers is using it, so it can't be that bad. What if I put this in and then twisted that one around to meet it? No, that wouldn't work. That wouldn't work. That has to go in like that. And this has to bend all the way back out. How the hell do they do this? How do they do this? I guess robots probably do it, right? Probably done by a robot that has all of the advantages, all the right leverages worked out already. So, man, that's a lot of tension. Yeah, that's a lot of tension. That's like starting to hurt. I'm smarter than this. I'm smarter than this. Would any of these work? Like the smallest security torques. I don't think it would, but I can try. Perfectly manageable right up until I have to put it into the little capture thing. All right, hang on. Hang on, I can figure this out. Go to the microscope. All right. We gotta load it up into this. I don't know if I could, I don't know if I'll be able to show you guys this. Keep my fingernail under this. Damn it! Magnetic ass screwdriver. Clearly not. What would a gunsmith do? A gunsmith would have all the proper tools. Guns are not this difficult. Ah, damn it. I had it. I had it for just a second, and then it exploded. All right, well, anyway, you guys get it. You guys get it. So, the Omnipod, how do it work? Well, pretty complicated. When you initially inject insulin into the thing, it fills up this, I know, it's low orbit. One day, mankind will find that as a relic of its time. So there's a couple things in play here. There's a lot of one-way mechanism. Bald Engineer, how you doing, buddy? How's it going? How's your hair? How's it going, Bald Engineer? Welcome to my shop. We got a couple things going on at once here, but we're trying to display how the Omnipod insulin delivery system works. I started the stream by actually loading one of these up with insulin and putting it on my body and starting to use it. I'm burning through these things like you wouldn't believe. I have an archive of these fucking things, so I got to figure out a way to take these apart, get the circuit board out, and I would love at some point, if I can figure it out, to put code onto the microcontroller as my own test platform. So not to test the insulin pump, but to use it for like projects and stuff. I think that would be super fun and cool if I used my derelict insulin supplies in order to run my diabetes, or run projects. This is an Omnipod, so I'm a type 1 diabetic. I need external insulin or I die an extraordinarily painful death. It's really quite handy how painful that death is. But anyway, it hurts the whole time. This right here is the way that I've decided to manage my insulin. I've got an app on my phone called Android APS. So Android APS is monitoring, it's basically, okay, there's actually two programs that are running. These are all programmed by diabetics. See, my glucose level sucks because I had a shrimp po' boy before streaming. So this thing right here is called Extra Plus. This is communicating with a patch on my body that has a little battery operated sensor that does glucose levels every 5 minutes with a 5-minute delay. So 5 minutes ago, my glucose level was embarrassingly high. But in the meantime, while those levels are being collected, this program is communicating with this program. And this program is managing the pod, this thing, and injecting tiny little amounts of insulin in order to manage my glucose level and to get it to go back down without it spiking down or anything like that. I actually probably have to tell this thing to inject a little bit of insulin. It thinks that I'm missing 4 grams of carbohydrate. Here's what I'm going to tell you. Maybe 8's a little bit. 8's a little strong. Oh, great. All right. Well, at least I have a keypad. Let's give 6 units of insulin. Bada bing. So now what happens is this thing uses Bluetooth low energy to tell the pod to inject insulin. How does it do that? Well, inside of the pod is all this nasty shit. So we've taken this apart pretty far at this point. Yeah, use OpenAPS? Yeah, I'm using apps. It's pretty damn good at its job. I'm pretty happy with it. I need to get into the automation stuff a little bit more with it. There's a couple things, and there's a lot of diabetics There's a lot of diabetics who are actually quite angry at Insulet for not designing a system that can be reused. Part of life with diabetes is supply chain management, and part of that supply chain management is making sure that you have the things that keep you running at all times. The problem is, insurance companies were like, hey, let's get involved. Hey, what are you doing? What are you doing with all the supplies? What is this? Hey. And in terms of prescribing things, now the doctors are the ones that give you a little bit of wiggle room, but the insurance companies make sure that you only have exactly enough supplies to get you to the next supply delivery, which is a problem. It's actually a big problem, because if anything happens, the disposable nature of these pumps say that you just take the thing off and you throw it out. With a regular insulin pump system, you have a device that has a motor in it that injects insulin, and you trade out, you change out the part that goes under the skin, the tube, and the reservoir. Well, this is everything all in one, right? Nearly impossible to get anything. You have to fight, tooth and nail for every single thing. Yep. But anyway, what Insulet decided to do is put an entire insulin pump on your body. So there's no tubing. There's just a little cannula, a little plastic tube that goes under the skin. That means that this device has to deposit the cannula and then inject insulin through it for a particular amount of time. Now, this is only 200 units in this reservoir. My typical insulin pump is 300, which is part of all of the annoying crap that happened with my supply chain management. In order to make these supplies last as long as possible, basically for any big meal, I'm just injecting insulin straight from the bottle. I'll just draw and inject with a syringe. And then I'll tell Android APS what I've done so that it can then manage all of my glucose levels and stuff like that. But so Insulet set out to make an insulin pump that was a single-use thing, cheap as possible, because that's always the goal, right? And have it function for a couple days. And so what they've done, this is like I forget what generation this is. This is like not the latest, but it's close to the latest generation. The design has been improved throughout the years to the point where I now would, wanted to use it. I've had a lot of fun with it. I think it's working really well for me. I keep reaching for my belt to try to find an insulin pump there, because let's say you have to poop, like you really have to poop, right? Imagine that. I don't have to imagine. Anyway, when you pull your pants down to poop, well, you've got like a little pager that's on your belt that has a tube that runs to a Band-Aid that hurts when you pull on it hard. So you have to unlink the pump from your belt, and then you can pull your pants down to poop. I don't have to do that anymore. I don't actually have to do that. Pretty cool. Oh, our 3D print finished. Good. When that cools down, I'll show you guys the thing that we've printed for the board. Anyway, how does this thing function? Well, you start by actually injecting insulin into it. So when you inject insulin into this thing, it'll load up this reservoir right here with insulin. In order to keep any mechanical interference, because fighting threads is not exactly something that you can do with just a syringe full of insulin, right? So in order to make this nice and capable of being retracted all the way, they have on their main gear mechanism right here a spiral gear that is not, it is being detensioned. So this spiral gear is being wound in such a way so that all of the spirals are expanded. As such, this thing can then travel all the way out, and this rod can extend and complete an electrical contact right next to it. Whatever. So it knows that it's filled with insulin, right? So then it starts twisting this thing. And as it starts twisting this thing, the part that's holding that spring under detention, I guess, that part slips into an opening here on the back of the reservoir. When it does that, it releases the spring, and then the gear is locked to the brass rod, so that during operation, as it spins the brass rod out, it will then move the plunger forward, and that's how it injects. But how is that moved? Well, in a typical insulin pump, this would be moved with a gear motor, but they don't have a gear motor in this thing. In fact, what they have is a piece of memory wire. Look at this thing. It's so cool. So there's one piece of memory wire in this device, and that would be this right here. The memory wire goes up and around a pulley, then it gets captured to this weird looking springy clippy thing, and then it goes down through another pulley to the next contact. But if it's on both sides of this thing, how does it operate stuff? Oh, this is not... Okay, fine. I can't clamp it in the clamp. I can't use the vise to hold on to it. So this is actually an electrical contact, and part of what's being read is that it is being advanced and retracted. So when this thing moves in either direction, it will complete an electrical contact with either of these two pegs, right? When it does that, the microcontroller knows that it successfully moved the gear mechanism forward however much these little gear arm thingies can push it. So it pushes against both of the gears when it goes in one direction or the other. But this is memory wire. So it has to actually heat up the memory wire to get it to retract to its original form. So if I take our power supply and I apply it to the entire memory wire, it doesn't actually move. This thing is using the end of this whatever it is, this little gear mechanism, it's using that as one of the contacts. So watch what happens when I apply power here. That heats up, and then this thing moves this way. Once it cools, if I go to the other contact, it'll move in the other direction. Maybe not as much, because I think I've destroyed this one. But so it just moves back and forth like that, advancing that gear forward. This is the replacement for a gear motor, and it is a piece of wire and a metal plate. It's absolutely wild. So not only do they detect when this thing moves, but they also detect sort of the major movement of this with this little castle piece on the top here. There's two springs that contact this little castle piece, so that when contact is completed, they know that they've turned the drum a certain amount. So they are still monitoring every single piece of the mechanism, but what they've managed to do is replace a motor with a singular piece of wire that simply tensions when you apply current to it and it heats up. You can see on the thermal imager. Of course, I think my power supply is also pulling back. That's why it's blinking like that. But this makes like a pretty strong clicking noise when it's in operation. You hear click, 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 click. At first, I thought these would just do the whole thing, but it doesn't move when you do that. It just simply tensions both sides at once. So, I hope that's interesting to you guys. This is like totally and completely unreversible science pitch. Mr. White. All right, so yeah. So this thing is pretty crazy, but what's going on up here? Well, we had one in the vise earlier, and I showed the operation of it, but what this is an enormous fuck-off spring that is held back by this singular little pawl, P-A-W-L, right here. You didn't know about memory wire? Oh, it's used in one of the science doodads in one of the Mars probes. So this little pawl right here is connected to this little ramp that pushes this copper tongue up and holds this plastic piece back. When this spring is 180 degrees twisted, it will want to shoot forward on its arm. So there's a little spring here that's holding this piece back. This piece is connected to the tube. This right here is a spring that is designed to allow the syringe to move forward and backwards without, breaking or whatever. So that's held in, like right here, and held into the reservoir with a little plastic thing. So when it's released, this whole mechanism springs forward, the tube gets captured with the syringe out, and then this retracts back and pulls the syringe away, leaving the tube. And it's all done with one single spring, and it's all held back by this little lever. So that once you prime this device, the flat spot in this gear wheel is in just the right position to then release that little plastic lever and inject the system. So that whole algorithm, that whole process happens thanks to this thing doing the only thing that it does, which is twist. 680% gain on pod? Is that Insulet? Is that the Insulet company? Teddy Minator! Some of the Prime for 2 months. Hey, Teddy Terminator. Teddy name Teddy. I don't know. That's the ticker? Okay. Yeah, their latest system has not been hacked yet, so I can't use Android, the Android AAPS. I can't use the program that I want to use on it because their control unit is just a cell phone. They had an app, but it didn't work on the Pixel 6. It works on previous like done operating systems. So annoying. They did not put a lot into their app, to be honest. And anyway, AAPS allows me to get way into the settings. It really lets me adjust stuff. As a tech person, I appreciate that. So I had to go back a generation and then use the dash, because these are Bluetooth low energy. Well, the Bluetooth low energy standard is a standard. So they know all of the over-the-air signals that this thing is using to communicate with stuff. So we're able to get our own modern cell phones functioning with a feedback loop code that has all kinds of features in it. All kinds of features in it. Where's my fingerprint? Yeah. Go away. Come back. I'm sorry I yelled. All right. We have all kinds of feedback loop features in there. For instance, it could detect that I'm currently sitting on a shelf and not able to get my glucose level to change significantly, and then it can take actions automatically. I still have to program that. What happens when you get too much insulin? You go hypoglycemic, and that you may have felt the effects of hypoglycemia before. If you haven't had a lot of carbohydrates and you exercise a lot, you get kind of shaky muscles, food tastes brilliant, you cold sweat, and you just generally are very shaky. It's a pretty dangerous condition because if you don't have the sugar required to run your own body, your body doesn't run. So you end up blacking out, you pass out. I actually white out. But can you die? Yeah, everybody can die, believe it or not. Everyone's capable of doing that. But yes, you can die from hypoglycemia. You can collapse. Yeah, you can run into all kinds of bad shit from going hypoglycemic. But food tastes really, really good when you're hypoglycemic. When you're hyperglycemic, the dire consequences are a little bit further out because eventually, if your glucose level doesn't get under control and you don't have any insulin in your body, because insulin doesn't just regulate glucose level, it does a bunch of other stuff. I can't get this detention, and it's really pissing me off. With the high blood glucose level, all kinds of different stuff happens in your body that can result in eventually turning your blood into acid. And as cool as that sounds, it's actually very, very painful. Your kidneys hurt quite a lot to the extreme, and your body produces ketones, and you go into ketoacidosis. It is a bad scene. I do not wish it on my worst enemies. Let's open up another one. Eyes go massive? I don't ever feel that. Everybody gets, by the way, the reason that I like read the comments and I'm like, ugh, you do that? Gross. It's because everybody has different symptoms. Everybody feels different stuff from their body, different feedback. For instance, I don't sleep when I'm low. I automatically wake up. It's just, that's like to a huge advantage, by the way. It's also why drinking and diabetes is so dangerous. That you need to be really responsible when you drink with diabetes, because as soon as your liver sees poison, we've got a little safety mechanism for going hypoglycemic, for going low in blood sugar. Your liver can actually release enzymes, glucagon, and get sugar production up and running to keep you from basically passing out and dying, right? Your liver can do that. But if you're drinking one little drop of alcohol and your liver goes, ah, fuck, we've been poisoned, and turns all of its operations over to the poison, that means you don't have that safety floor of glucagon from your liver. So if you drink a lot and you're getting a lot of activity, you can pass out pretty hard. It's so eating when drinking while diabetic is kind of important. Yes, that wonderful joke. Is it safe to have a device on your body someone can hack into and dump a whole load of insulin? So, about that. Back in the early 2000s, when everything was on 433 megahertz, a lot of the stuff that's been transmitted over the air on 433 megahertz is not encrypted, which was great because we were able to make a man-in-the-middle type device that would receive the 433 megahertz and then talk to the phone via Bluetooth. And things were good for a little while in terms of that. But then the press got involved, and they discovered, I published an article that says, hackers can get into your insulin pump, and you have a picture of somebody in a baklava on their laptop going, I'm in. So the thought was, oh no, somebody can inject you with insulin. But, you know, bodies are weird. Over billions of years, we have evolved to be able to turn food into sugar at an extraordinarily rapid pace. I actually have a superpower in regards to that. I can digest white bread faster than anyone on the planet and turn it into blood glucose. And I'm diabetic. It's a wonderful little Achilles heel of that ability. But anyway, you drink sugary stuff and your liver can actually help you out and give you sugar in advance. So it's like, oh, you're having something sugary? Here, let's release sugar into the bloodstream. Now, all that's really frustrating for your diabetic because insulin, external insulin that your body did not make, does not react very fast. And in fact, we injected it in interstitial fluid, which is the stuff that's between your muscles and your skin and stuff like that. Your muscles and your skin and stuff like that will absorb it, and they absorb it slowly. It can take a lot of time to absorb the insulin. Fast-acting insulins are better at this. Insulin is this giant fucking structure, and it's actually so big and fragile that if they don't put stabilizers in the insulin, you could do this, and you get clouds of tangled up and destroyed proteins in the bottle of insulin. I used to have an insulin that was prone to that, and with the T-Slim, there was a little tiny cylinder that would draw and inject insulin, and just that little tiny cylinder drawing and injecting was enough to disturb the fast-acting insulin to the degree where it would clog the tube. It would cause occlusions. After having fought to have that pump for so long, I then had to be like, I need a different insulin on this. Because nobody's found this to happen yet. So, insulin takes a long time to lower your blood sugar. If a hacker were to randomly, somewhere in my day, hack into my pump, and I'm like, hey, what are you doing over there in the bushes? And they're like, oh my God, and they run away with their little baklava on and everything. If they were to have injected me with insulin, I would see the glucose level dipping on this thing. If it was too fast for me, and I've had that happen before where I passed out because my glucose level went, and I was drinking at the time too. It was really bad. It was at a festival. I thought I was in a field, like a dreamy, misty field for a little while. And then I finally woke up to the medical people shoving Gatorade in my face. But anyway, but that was because of exercise too. I had been swimming. That crash in the glucose level, a lot of diabetics will feel that very, very sharply, and they'll typically be within access of some kind of a heavy sugary thing like Gatorade or orange juice. So really it was just a lot of fear mongering. But what that article did in sort of outing the hacking of insulin pumps, you see, they were using the term hacking. It's actually the hacking that people are doing is closing the loop and making their own software to run everything. That's the type of hacking, or like the hacking that we do here. We do a little bit of reverse engineering and hacking in terms of like, Hackers the movie. But what we typically do here is hacking, like hardware hacking stuff together. The traditional term, the traditional use of that word. And that's what the diabetics were doing. But so the pump companies got wind of this and they said, hey, how would you guys like to decrypt AE286 over-the-air communications? And they put a shitload of encryption on all their stuff. There was a $20,000, I believe, bounty on getting the secret keys, the encryption key to the Omnipod insulin pump. And if you look on the internet, there is an article about the type of reverse engineering that they did to these things. Not the previous version. This is Bluetooth, so we know how to control it, because the Bluetooth low energy standard is a standardization so that you can have like 100 Bluetooth devices in a room at once and they can all function properly. That's why these companies had to go to the standard. But the 433 megahertz version of those things then involved heavy encryption. And what they ended up doing is taking it apart like we are, taking the chip, shaving off layers of the chip, sanding off layers of the chip. Oh no, actually no, they didn't sand it off. They used acid. They used a particularly mean acid to boil off the epoxy on top of the chip, and then they visually observed it in a microscope to find the memory, and they looked closely at that memory, and they used MATLAB in order to figure out what gates of the memory were set to ones and what gates of the memory were set to zeros. And so doing that, they were able to produce a hex file that was basically the code, all of the code of the insulin pump. They then reverse engineered that code. There are tools to help you do that. And then figured out what the secret keys were. That's some try hard. It was a university. Only a university's going to have that much. See, when I started streaming, I actually was trying to get somebody to send me a bunch of their dead pumps so that I could open it up and see if there was anything a professional IED reverse engineer, could figure out. There wasn't. There wasn't anything I could figure out, because as soon as I started looking into it, I found that the PDF of what they were doing, and I was like, oh, they really did a good job of that, huh? I don't think I can do that. I don't have like a scanning electron microscope. We do have a good microscope, but man, like plugging it into MATLAB and then figuring out where the ones and the zeros are, what? You boil it down, all this electronics is actually a physical device. It all exists. You know, learning analog electronics is important, because even if you are permanently in the digital world, you are eventually going to run into analog signals. So it turns out that even memory storage is actually a physical thing, and you could observe it visually. Wild. Maybe someday, yeah, I could start building one right now. I know a lot of these fucking popular YouTubers have their scanning electron microscopes. We only have a Logitech webcam that's it's taped to a stick. Yeah, there's the article if you guys are interested. Freaking crazy stuff. So my goal here, and this is not something that I can achieve anytime soon, my goal here is to eventually put this onto a board of my making, because it seems really, really wasteful to me to have an entire microcontroller that you use for 2 days and then throw out. I know in the grand scheme of things that's probably fine, but well, they had to go over to the standard of Bluetooth low energy, and I think they slacked up a little bit on the whole locking diabetics out of stuff, because it seems like, you know, the we will not wait people, the people who are doing all of this reverse engineering and stuff, have sort of made inroads that the companies saw and decided to then spearhead innovation instead of stagnation. So they decided to actually work with diabetics a little bit and decided to actually not super duper lock everything down, and everybody has started to close the feedback loop with the constant glucose monitor, even though the constant glucose monitor has been around for so long. Bluetooth low energy is encrypted, but there are lots of tools to figure all that out. Yeah, I think Insulet was kind of cool and worked with diabetes. I can't say anything properly today, chat. They decided to work with diabetics a little bit in terms of like opening their device up. I don't know, the new version of this pump, the Omnipod 5, is a different environment. In fact, it's got a couple different chips on it and slightly more comprehensive electronics, because it's designed to function without the phone in the picture. So if you use the phone to configure it, but then it will respond to changes in glucose level, which is not something that I'm ever going to do. So I want to have the phone, you know, I want to have these tools, and it's going to take these guys a while to get What? What are you talking about? Pod not activated. I think that's an old alert. Yeah, that's an old alert. Why does that stay up? Get out of here. And now forever the Android APS is going to have a... Okay, no, never mind. Fixed it. Okay. Anyway, sorry. Why do companies use epoxies on circuits? What's the point of obscuring the chip if the product is just going to be thrown away? I would wonder about, yeah, whether or not they would go to a glob top or just have the chip with the bonding wires and then do an epoxy cap on it. I don't know. They're not quite there. They don't quite do that. But all of these part numbers, by the way, you're not going to be able to find any information on this chip because this is specifically engineered for Insulet. NXP bought Freescale Semiconductor. Freescale was the integrated circuits that used to be on this thing. Nowadays, they're NXP, same company. What they've done is Insulet said, hey, we're selling like 1 million of these things a year. We would like to work with your application engineers so that we can have a cheaper all-in-one solution that's going to do all of the functions of this pump. So in here, there's likely to be slightly different registers for all the ones and the zeros to fall into. And then there's going to be like switching equipment in there too, in order to, for instance, put power over to the memory wire to run the piezoelectric buzzer. And then of course there's integrated Bluetooth in the device as well. It is a nifty little setup here, and I don't know if I'll be able to... The problem is, I don't have any information on this at all. So I don't know where the registers are. It is likely to be a similar part number to like a popular microcontroller. How fucking dare you say that in my chat? Do you understand what you've just done to me? If you guys like actual pyrography, like wood burning, check out ADHD Degenerate. He does a lot of cool stuff. He also sent me all of these little coasters that you see taped up to the side of the shop all over the place. Like that, the emote coaster right there. That's him. That's his art. ADHD Degenerate. You guys check him out. Thanks for watching commercial. No. In general, you're an expert in circuits. I was wondering if you knew what. Did I miss a comment? What did Tuna say before? Oh, why do companies use epoxy on circuits? What's the point of obscuring the chip if the product's just going to be thrown away? Well, I mean, I don't know. I guess I don't understand the question because companies do, like when you have a device that's like really mass produced, they will put the silicon die directly down on the PCB and use bonding wires on it and then just put a dollop of epoxy on top. And the reason that you put epoxy on chips at all is to protect them. You don't want that to be in the open air. That's a very sensitive piece of silicon that we've etched in a very particular way. And you get one fingerprint on that thing and the whole thing blows up. So, yeah, and I guess vibration and moisture. But yeah. I've got them all over the shop. They're actually, I don't know, it's kind of hard to notice. Like there's one right behind chat right there. Opposite engineer of bother. What? Are you mechanical? He's also Canadian, but don't hold that against him because he can't help it. So the thing is, like, I don't know anything about this chip. The document that we have, reverse engineering, the super duper smart academic people that nanomaterials and fracture mechanics. Fracture mechanics are neat. Oh, you did materials engineering. Materials engineering were the big brain people at my college. Those materials engineers were like on another level. Yeah, that's the thing, like single-use device, you would think that they would use a glob top on this, but they just didn't. Not a glob top. A glob top's actually something else. Glob top is when you're developing your ASIC, you get sent them from a company, and what they have is a generic, like a generic chip enclosure like this, but instead of the labels and markings, they've put your ASIC down on it and done all the bonding wires by, well, manually, I should say. And then they put epoxy in there. So the top is all like wavy, but then the chip around it is solid. That's what a glob top is. We can be. But yeah, if you were making like millions of disposable devices, the way to do it would be to put the chip directly down on the board and then epoxy around it. But I don't see that a lot with more complicated microcontrollers. Also, I have no idea what this thing is. It's probably memory storage. It's an I2C device. You can see by two lines going back to the main micro. So I think this thing is probably an EEPROM, which begs the question, why didn't they just put an EEPROM into this thing? Why isn't it just one device? I just hear a beep. I heard a beep. Something beep? You beep at me? No, you weren't beeping. What was beeping? Did it complete a circuit? No, it might have been outside. Anyway, yeah, I don't know. I hate the fact that this thing is so unreusable. As a 200 unit reservoir, you tend to burn through these things a lot faster than with normal insulin pump supplies. It's disheartening, but after looking at the engineering that goes into this thing, there's no way I can reuse it. I just can't. I can't recharge the device at all. There's no way to do that. I would have to get in here, retension the plunger spring, screw it in. Then what? Hold on. Thinking. How would you, because if it injects, it's not like anything opens up. So what keeps insulin from flowing out of this thing when you're filling it? You fill it, this thing snaps. There's no differentiation between insulin going in here and coming out of the other end. How does that work? Wait a minute. We've got another mystery to solve, gang. How does that work? Because this thing is just, this thing is just like a seal. It's just a glass bead that's used to seal against the plastic. That's open. This thing would be tensioned. So this thing is 180 degrees spun. God, there's an actual fucking needle on the end of this thing. I really don't want to stab myself. With that in any of the positions, it's not like it's cut off. So does insulin just free flow out of here? Why wouldn't the plunger not move? Why would not to being this way? What is happening to my brain today? My brain is just dissolving, chat. My brain is just dissolving. I showed all the raiders this thing functioning, right? The memory wire mechanism. Pretty cool that they use it. Yeah, I did. Okay. For those who haven't seen it, I'll just use it again because we got the thermal cam and everything going, right? So this right here, it is, yeah. It's a mass-produced chip. They probably have whatever NXP microcontroller is in that family and that packaging likely is very, very similar to this device. And you would look for one that that has Bluetooth integrated in it, and they probably just put like a couple transistors in there in order to manage, like, you know, the high current memory wire or whatever. I don't know how much force the memory wire has. It seems like it has a lot because of what they ask it to do. But check this out. So what happens is current runs through the memory wire and heats it up. And when it heats up, it tensions. Oops, I didn't show that on thermals. Sorry. Where are my thermal cameras? Please. There we go. I would like to get a little closer, actually. Closer with the thermals. There we go. Okay, so now you can see the metal is reflecting the heat of my lights, just so you know. So when this thing gets current through it, heats up that end, pulls it, and then this thing moves towards me. Current goes this way. It does the opposite, and it does it very quickly, too. I wish I could get like a more permanent connection up here so that it could be displayed, but I guess it doesn't move back far enough to hit this. I thought it did. Maybe it does. Maybe we'll look at the other one and see what it does. Yeah, but insulin doesn't have high viscosity. Insulin is very liquidy. Yeah, I guess it's just a factor of the restriction. You know, the restriction of having it move out of the syringe. But it's coming from a syringe. That's the thing. You poke it into that thing and then it injects through there. Is there some other one-way mechanism in this? There's a lot of one-way mechanisms in this design, and it's extremely clever. I'm tickled pink by the amount of engineering that goes into this thing. Is there some kind of a cutoff on this? Doesn't look like it. I don't see no cutoff there. If this thing could somehow snap into place and... Doesn't look like it. How does it know? It keeps hot things hot and cold things cold. How do it know? I'm appalled. I am appalled. What's that thing for? Oh, I think that's for the buzzer. So, yeah. I guess it is just by virtue of... Maybe that's how it... Maybe it actually does prime itself that way. Could you rig it to test how it works without the cover on? No. I would need... First of all, I need water to inject, which I guess that's easy to get. I don't want to sacrifice a good pod. That's for sure. And then this mechanism is the one that pisses me off the most. This one is the one that I can't reset with my hands. This one right here. This is how this thing captures the plunger, and it is a loop spring, right? It's a twisty spring. When you twist the spring in one direction, all of the pieces of the spring move apart. When you twist it in the other one, they all move together. So this rod that is attached to the plunger, this brass rod is threaded on the inside. And when it spins, it will advance the plunger. But again, because you have that syringe coming off of the other end, you don't want to put any mechanical resistance on this plunger so that when you fill it with insulin, it fills the reservoir and doesn't squirt out at the end. So that brass rod goes through this spring, which is held by this little piece of metal right here. This little piece of metal on the end of the gear. When it's under no tension, or sorry, when it's under opposite tension, this will slide in completely unabetted, right? It'll just slide right in all the way to your fill level. And when it spins, it will be fighting against this metal plate because the spring is trying to move that metal out of the way and then do its spring thing, right? Until you reach this cutout in the opening. When you reach that cutout in the opening, this thing is allowed to lift and it releases that spring. The spring snaps into tension and grabs onto the brass rod. And so as that thing spins, it is working with the spring to keep tension and twist. Isn't that crazy? They're using a spring to grab a brass rod. And then this is just an electrical connector that tells the microcontroller that you've filled the pump to a certain amount. Yeah, it wouldn't be surface tension, but yeah, it's just pressure keeping everything inside. We're lucky our bodies aren't under positive pressure, or else it would be a disaster for injecting stuff. You know, the device isn't simple. The mechanisms are kind of simple, but there's a lot of really clever engineering behind it. But you're right, I am tickled pink by this fucking thing. This thing is so cool. So weird. Unfortunately, it is also completely disposable, and I hate that. I was hoping I'd have some kind of a breakthrough. Wait a second, what is all this? Oh, that's just insulin in there. Is this some kind of a valve? Oh no, it's just upside down. It goes this way. This is the rubber stopper that you have to put the needle through in order to fill this. Yeah, I don't understand how this doesn't like pop off or not deliver insulin. How does that work? It really is just a glass bead on the end of it that's pushed into the plastic. So I guess it is just always exposed. I suppose you're overwhelming, like this moves more easily than this allows insulin to pass through. You put a line on messing with medical stuff? I do not. I do not. There's some of the most fun things for us to work with. The T-Slim insulin pump that we took apart, I still have the very nice, although pretty cheap if you go on Alibaba, the gear motor. It's like a Swiss gear motor. You can find them on eBay for much cheaper than, a $5,000 insulin pump. I don't understand how it blocks. I guess maybe it just doesn't. It doesn't. Very crazy. Cool. Well, I think we've explored this pretty thoroughly. I think we've got a really good idea of how the insulin pump works, and unfortunately, I didn't find a goddamn thing about reusing it. There's absolutely nothing that I can do. Pretty crazy. Let's play with LEDs for a minute. Sorry, I gotta stretch. Difference between a tinker and an engineer? I guess, yeah. I don't... engineering just teaches you certain kinds of discipline, I think. Like, traditional engineering. What is nice is that there's all kinds of resources for the tinkerer to have the knowledge of the actual engineer, including but not limited to a Twitch show where some weirdo takes stuff apart. But yeah, the tools that are at the fingertips of the average electrical noodler, those tools have improved so much over time. It used to be that you had to have like a very specific type of programmer for a microcontroller, and you had to learn all the different what all the different registers do, and how to set all of the setup bits so that you don't brick your microcontroller, etc., etc., etc. There's just such a nice open scene now for all that stuff, and the programming tools have gotten much cheaper, etc. Sticking your fingers in a toaster and learning that electricity hurts while being 10. Yeah. You take one shower with a toaster and nobody forgives you. Be worrying about messing with a medical device that I need to use again. Yes. Yeah, that's a good line. Good line to draw is, you know, if I got to use this thing again, I don't think I'm going to be hacking into it. Although the hacking that they've done in terms of signal manipulation in order to get these things functioning with your own app is pretty impressive. But again, those guys are also working with people who have that knowledge, have all of the, you know, the medical know-how and the control systems know-how in order to do that type of project. I don't know. Tools are getting more powerful. The things we can do are getting better. It's all good. This is the side of Burn the Subs. Burn the Subs is my laser etching XY table. I say table, but I mean, you know, it's on the wall. But it's a giant XY laser etching board. And what we're trying to do is make a slightly more professional version of it by giving it all of those little touches, all the little things that I wanted to do with the board on a hardware update. We have software for it, but we are changing the way that the software is interacting with everything. So we're going to be moving it over to Klipper, and Klipper is going to be using it like an XY table. Klipper has the ability to look ahead of the inertia and stuff like that and make sure that my laser moves in a good way. What we used before was called Gerbil, and it did the same thing. We're using Klipper because we have leftover from 3D printer upgrades. I have a nice SKR board with the nice trinamic drivers and everything, and it's going to be running on a Raspberry Pi. There's going to be a lot of software stuff to do, but before we do software, I am doing the hardware. So we have decided to do a DB connector, 2 disconnects for water, and then we have a 5.1, and it's very specifically 5.1 volts because the Raspberry Pi is very particular about the power that it gets. So 5.1 volts, 12 volts, that runs the pump and stuff, 24 volts, which runs the motors and stuff. That's a voltage bus okay, and then this is the AC okay light. So if all of these are lit up, that means that system status is good to go. This panel is designed specifically to hold up the Vicor power supply. I decided to use the nicest power supply that I have as an electrical engineer and just generally somebody who ends up getting their hands dirty inside of electronics. I wind up with a lot of power supplies. People say, hey, you want a power supply? And I say, no, because I get too many of them. Everybody sends me fucking power supplies. What am I supposed to do with them? I have every kind of computer power supply in existence in multiples now. I have every kind of wall wart in a bin. I don't want your fucking power supply or your old computer. Why do they do that? Anyway, so everyone and their dog sends me goddamn power supplies. This is the only one I've bought in the last decade. This one is a 24-volt Vicor power supply that has 1 billion amps behind it. Has 1 billion amps behind it. I really should have put this in the 3D printer. That would have been a good place for it because I use the 3D printer a lot more. But we're going to put it on Burn the Subs because it's not going to get a use anywhere else otherwise. No, my 3D printer is a single filament. It's a single filament. So what this panel is supposed to do, go right there. And then I can put all of the wires that are going to externally run the board to a DB connector that I can unplug. So we have the fluid cutoff connectors. Those are on their way from China. The only place I could get them at a reasonable price is from China. Now there is a water system running in this. I have a reservoir and a pump all the way up there. I probably should put the reservoir and pump somewhere else, but I mean, conveniently, there is a big blank space to the right of the board, right there. So that's where the control panel goes, and it's rather thin. It probably would be better if I could like spread out and have it in more of a square. That, you know, maybe one day. But for now, we're making this sort of weird stack of electronics. And also, I probably really should have done Eurorack style. Eurorack would have been probably better. Whatever, who cares? So yeah, this panel goes in there. It has the status lights from this. It will have LEDs connected to the other voltages. These are basically going to be directly connected. And in order to make it look cool, we decided to do indicator lights and dual filament print. The way you do this with Klipper specifically, there's an issue that I had to resolve at the beginning of stream. When you pause a print, you're pausing in Octoprint. I use Klipper and Octoprint, right? So in Octoprint, when you tell Klipper and Octoprint to pause, it pauses both of them. When you hit resume, it resumes Octoprint. So Octoprint would continue to send G-code, but Klipper wouldn't be informed of anything. So what happens when you do another filament change to resume your normal color, because you need stuff to block light, when you go back and you resume that print, the second time, Klipper isn't running, I guess. I don't know. Klipper still thinks it's paused. And so it just ignores the pause. So what I had to do is install a plugin. And the plugin allows for, like, I guess, more advanced commands or something in console. And I made a button that would resume both at the same time. So it resumes, and then it resumes Octoprint in one instant. And so that way, I can have Super Slicer say, hey, do a filament change, M600, at this line. So right before the next layer, it'll pause, move the head over, and get ready for a filament change. And then I can prime the nozzle and clean it and all that stuff. And it'll come back and it'll print right on top of itself. So this way we can make light guides. That's what the cool part is. That's all cool kids can do. If I had a dual filament printer, I could fill this in and just have the clear stuff where I wanted it. But I don't have a dual filament printer, so I had to do this by making a stripe down the entire print. But what that does is that allows us to have these little windows that I can illuminate. And I'll probably be doing it with surface mount LEDs. We'll try that in just a minute. The surface mount LEDs at least can spread the light out more. But let's just take a look at what it looks like with a regular LED on it. So I'm just going to take this one, and I'll turn my power supply down all the way to 2 volts. 2 volts. What I really should be doing is limiting the amount of current, but whatever. Oh, this is all very easy. Easy peasy stuff. But yeah, there's a large contingency of people who watch this channel who have absolutely no idea what I'm saying. They're like, I don't know what you're saying, but I like watching you. Was I seeing a spark? No. Oh, it was just the light reflecting on the front of the probe. I thought I saw this thing sparking. I was like, what the hell's going on? Jeez. You guys watching the show not knowing what the hell's going on. We don't shy away from advanced projects here. We've done some pretty intense stuff in the past. I reverse engineered a Bluetooth low energy steering wheel device. I watch to watch. I watch, therefore I am. Uh-oh, I might have put too much filament behind it. Oh, no, never mind. The LED is just complaining. I think I'm burning it out. Oh, the LED. Oh, oh dear. Oh dear. I think this LED is dead. I think I killed it. Oh no, never mind. It's okay. I thought I was dying. I thought you was dying. Oh, geez, I'm gonna need a lot of light. These might be getting the maximum amount of... Oh no, never mind. Here we go. So you can see it from the side. Interesting. That is a good diffuser, though. That is well diffused. There's a little bit of sparkles where the light is concentrated. How does that look for Mark 1 eyeballs? Doesn't look all that good from out here. With the amount of light bleeding that's happening, it's good that it's like that. Sus. That's sus light. Sus. Sus. Amogus. Sus. Sus. So I might need to put 2 LEDs behind each one. I mean, if I could get it out here, that'd be great and all. But let's see what surface mount LEDs look like. And we'll actually put resistors on these. So I'm going to get a little piece of circuit board. I mean, I could do a big piece of circuit board. Yeah, let's take this one. So I'll go... Let's see. Just outside those. And then this row, second row. Okay. It's going to take a lot of cutting. Oh, and I have an ESP on this thing. Maybe I shouldn't take this board. Sus. I literally know dick all about electrical engineering, though. Well, it's all right. You know more than most people just by listening to this channel. I'll tell you that much. We got osmosis in effect over here. The ones I have a different light spread to them. The light is going out at a better angle for this sort of thing. I really would rather this be... I think I've run out of my good surface mount board, though. I had this white stuff that... I need to find another surface mount PCB and order like 20 of them. Because, yeah, I'm out of this stuff, which was the square hole, the square pad, single-sided. This stuff is best for surface mount because you can use... you can do stuff like this, where you put tape down and you get an entire IC on the board. By virtue of the squares, that means that you can bridge the squares with surface mount parts more easily. I'm going to see if I've got a piece of derelict board sitting around. I thought I had like a whole good one still in the packaging. Nah, it's not over there. Okay, never mind. We got to make do with what we have, chat. We're going to make this work. We're not going to design an entire PCB for this. I do need to go through all of my PCB design stuff in Fusion so that I can get parts that I know are good and have 3D models that are proper and put that all in one place so that I can then load up that library and work from known goods. It'll make my... Oh, that was a really hard burp. It'll make any of the PCB production that I do so much faster. I don't know when I'm going to get around to doing that, though. All right, we'll just use this piece of board that I had sitting over here. It's the one that we used yesterday. So I'll use this, put it in a big vise. By the way, tomorrow we are playing games. I have to do it. I have to do it or I'm going to have a fucking mental break. I've been able to play games for like weeks now. I don't know what's wrong with me. I get done stream and I'm just kind of like mentally done. I go and play with a dog. That's what I've been doing. I haven't had time for games. I really should... You know what I should have done, chat? What am I playing tomorrow? It's probably going to be my summer car. I feel like I need to close the book on that rally. I don't think I'm going to be able to win the senior rally, but the junior rally, I've got my eye on it. And then we can branch back out to other games. I miss Jedi Knight 2. we played a little Jedi Academy for a bit. I want to get back to that. I don't know if I'll end up playing that game or something else. Personally, I've been playing Disco Elysium, sort of. I haven't gotten to it in so long. Okay, these have lenses on them. These don't. Those are whites, though. I don't want to use a white LED. Let's see if we can find a better surface mount LED. I ordered a bunch. But yeah, I really should have gone with the Steam Deck instead of buying a modern, at the time, graphics card. Because I would have many more opportunities to use the Steam Deck while babysitting the dog. I do have a Fire Stick that has Twitch on it, though, so I'll end up in somebody's Twitch chat typing on my phone. I'll tell you something, ADHD. I I agree with you absolutely and completely on that one. Everybody gets like shithoused and then starts screaming over each other, and I just can't. I just can't do it. That I've been in that camp for a long time actually, where you know we did like a what do you call it? We did a rec fest night, and it was just chaos. And I was like, you know, I'm good. I'm good. I don't need to do this. Also, I'm too introverted for that shit, says the guy that's currently on camera. So these are actually the ones without lenses. Okay. Red, blue, yellow, white, pink, ultraviolet. We're not using that. Green, yellow, blue, red. I'm tempted to use pink in this instance. I don't mind hunt. 3 people. Oh, yeah. More than 4, and it's nuts. Well, you know, my mixer does audio ducking, and that's not just me trying to type something else into my phone. Audio ducking, for when you're talking, everybody else's volume goes down just a little bit. And it helps. It helps a lot to kind of retain control over your stream. Especially when you have a fucking shithouse of people screaming over one another. Red because it goes faster. Red LEDs are kind of old, right? They're kind of like old news. Not wrong, though. I'm going to put a pink LED on the board, just so we can see it. I'm not using a UV because it damages plastic. I don't even know why I bought the UVs, all right? I don't know. I wasn't making good decisions at the time. I should have gotten a different color. Radio Shack green. I mean, green light, red light, you know? We'll start with 1, and we'll add another if we need it. So for the LEDs to be bright, I'm going to use a 1 kilo ohm resistor because I don't feel like thinking or doing any equations at all. So 1 kilo ohm resistor. 10K would be if you're directly viewing the LED on the board. If you're directly viewing it, put a 10K ohm resistor in there because it'll keep, like if you're not trying to illuminate anything, if you're just trying to use an LED as an indicator, put a big resistor on it. You can't be trusted to pull back the power to these fucking brutally bright LEDs. They'll hurt your eyes. But when I'm putting an LED in a circuit, you know, like 300, 600 ohms will be absolute maximum blast. I'm just going to put 1K on it. And I'd have to do a different equation for the different brightnesses or for the different voltages. But this is just an illumination test. Another thing that's important to do when you're designing something that people will be like LEDs that people will look at, even if you have PWM running to your LEDs, managing the resistors so that the brightnesses of your different colors are all even is an important step that a lot of people neglect. In fact, God, when the blue LED came around, it was a plague. It was an absolute nightmare because all of these companies would start putting blue LEDs into everything, right? This is like the 1998, 99, 2000. They would put blue LEDs in everything, and back then it was an extremely hungry chip. There was a lot of current that would go to that, and they would be very, 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 very bright. So everything had fucking monstrously bright blue LEDs on it. The top of the T is positive, so I got to remember that positive is on my right. Positive is in the anode. Negative is the cathode. Negative is the cathode. I'm going to go middle of the board here, because this is just our test board. We're just kind of throwing it behind stuff. I'll go to the middle right now, and we can move it if we need to. So, all right, let me get my solder. Sorry, solder. Solder. It's just solder. Yeah, 1K is just like the easy. It's just easy, you know. Yeah, back then the phosphors, the phosphor coatings were different on the blue LEDs. So you had blue LEDs, but they'd run at 5 volts. Like a full 5 volts, which is crazy. They were not efficient at all. And then I guess there was a bunch of phosphorescent coating stuff that was developed that wound up making it more efficient. It still relies, all these colored LEDs rely on different phosphors under ultraviolet. Oh, that droopy solder in the background. What the? It's not enough solder for me to cover the whole thing. Hey, there you go. Been a while since I've soldered something. Solder? Yeah, it's the Brits, man. And they keep at me about aluminum. But I don't know where all those extra syllables are coming from. Aluminium. If you really want to call it what it's called, we looked it up. It's aluminum. So you're all wrong. All of you. Get out of my house. Resistor on the positive or the negative? I guess it doesn't really matter. We'll put it on the negative. Not using the microscope for this. I don't need it. Mark 1 eyeballs. Those will be just fine. All right, so there's our pink LED. If we put, what voltage on it? 5? Let me, hold on. I got a 3, 4, 5 volts. We'll put 5 volts on it. We'll get beautiful pink. Hello? Beautiful. There it is. Beautiful. Look at that. Look at that. Call it AI. Yeah, I don't think red is UV. The like original red and greens are not. But weirdos like this. Wire. 2 wires. I'm gonna get wire from the end of the bench here. Dude that discovered AI flip-flopped on the spelling and pronunciation throughout his entire life. Oh, would he call it A? A? Hey man, what are you working on? Just my Bro, just say AI. What, you mean like my Oh, it's a lowercase L. AL. Oh, aluminum. Yeah. Aluminum versus aluminum versus aluminium. But I mean, it's not titanium. So shut up. It's not titanium. Just like Oregon, you turn a light switch on. Oregon. It's fine. Stop bitching about it. That's how I feel. My express opinions don't reflect that of any other aspect of my stream. Yeah, platinum. Titanium? I hate it. I hate it, and I think worse of you for it. We're all collectively dumber thanks to your response. Have a good day. I forget that full quote. I was going to quote whatever that Adam Sandler thing is, but whatever. Ah, damn it. Stay in here. It's the ends are a little uneven, so it like pivots. Who says titanium? You find them every now and then in the wild. Can't mess up Idaho. Idaho messes up everyone else. Or no, it's Ohio. I need to be able to see what I'm doing a little better. So we go to the microscope. Where's my soldering iron? Solder. I know it was a joke. I'm messing around. Expect clap back even for jokes, just because I'm joking too. Please down on the board. Thank you. Having a full reel of solder is a different experience. It's hard. It's like hard for me to dispense little bits of the solder. I probably should have bought half of the amount that I did. I got much finer solder now though, so I've got much better command over surface mount stuff. I don't know. I'm being very ponderously slow in building this. I probably could have just wang-jangled something together a lot faster. Where did the black wire go that I had out here? Did it fall? Did it go home? Where? Oh, it's on my lap somehow. There we go. It's on my lap. On me lap. Bruv. Oi, bruv. Yeah, do you... this joke doesn't work if, because I need to type it out, but you just type it out the same thing twice and say, hey, do you pronounce it this or this? I can't do that. You guys can do that. I can't. It's just not a joke I can manage. This is going to fall off if I don't hold it still. Yeah, everything is solder now. Everything I know and love, solder. That house over there, solder. My beautiful wife, solder. Everything is solder. This is the sloppiest fucking LED circuit that I've ever put together. I don't know about you guys. But I am just messing a boot. You're Binar from like the 3rd episode of Star Trek? Or no, that's from Starship Mine, isn't it? That's the one where Picard found his way onto the script for oh fuck, why can't I remember anything right now? Die Hard. That's Die Hard in space. No, wait, the Binars were... Yeah, the Binars were different. That's when they both fucking fell in love with the same computer program. That's a different one. That's a different episode entirely. So, first of all, my soldering prevents this thing from fitting properly, but the better spread of light from the chip LED, that's nice. That's actually really nice. That's nice. I like that. Pretty nice. Yeah, yeah. I mean, if I put 2 of them behind there, I don't think that's going to really improve things much. It would just light up the corners a little bit more, but the diffusion is there. Of course, you'll be able to see it over there, but luckily the power supply is going to cover that over. I think just one of these LEDs with a 1K ohm resistor, well, actually, the resistor is going to have to change for the different voltages, so the 24, 12, and 5 are going to get, you know, different values of resistor in order to keep them, but... Yeah, they need a spaceship computer to back up all of their collective knowledge. That's right, I remember that now. we need to use your computer as like a hard drive. Federation is like, what? Like, we could just like put a computer in a cargo bay. You guys knew about this like long in advance. Why didn't you fucking tell anybody? You irresponsible fucking aliens. What's wrong with you? You fucked all of us over. Except for Picard and Riker, who fell in love with the same computer program, which is a little creepy. We gotta kind of talk to them about that. Yeah, why would a ship's... Well, it was because basically it's a flying power plant, and they hooked a giant computer up to that power plant was the justification. That's apparently like that level of power to run such a large computer only existed in something that has a warp drive, I guess. I think that's what the Daystrom people would say. I don't know, though. There's Gene Roddenberry just coming up with shit, you know? Yeah, it'll be the bestest ship in the world, and it has all of the guns, and it has all the computers that you could ever want. They can run Minecraft in a room. And then also the holodeck computers weren't compatible with everything else. The holodeck always had this incompatibility issue because it wasn't allowed to be the magic sauce that solved every problem every time. This looks really good. Do you think that we should go with blue or something? It would be kind of generic if these lit up like blue. Red is probably out of the question. Pink is kind of fun. Maybe we'll just make them all pink. Pink isn't really a theme on the Burn the Subs design. Voyager uploads are called downloads, and downloading would remove data from where you downloaded it automatically. They would constantly bitch about the bio computers too. Like, oh, it uses biology in order to make the computers more computer. It's like, all right. They really dropped the ball on Voyager, though. It would be better if it was a little bit less episodic, you know? Can you see it with heavy lights in the room? If you can see it on camera, that means that you can see it under heavy lights, because I've got a lot of lighting. It'll be in a slightly shadier spot with a much more warm lighting than what I have on it right now. We can kind of barely see it, and that's good, because I don't want it to blast out my freaking retina every time I try to look, and I don't want it to illuminate the entire room. I want it to be pretty much just something you glance at and see. Yeah. Yeah, the 3mm LED has a big lens on it, and that causes the cone of light to be much more narrow. So in order to get the same level of illumination on the whole thing, it would have to be like out here, like right about here. So instead, just using a surface mount LED that's emitting light in all directions. This isn't very bright, is it? But it's good. It doesn't have to be very bright. Jippercorn, thank you for the Prime for 31 months. It's a lot of months. I appreciate your support in this matter. Well, that's good. That's really good. Looks a little sus, though. It's a little sus. What's cool is that the border around the box, I could also illuminate if I feel like it. Although it doesn't seem to be taking light very well. Put some tape on it. Yeah, for this thing that I'm designing right now, I'm going to modify it after the fact. You freaking idiot. Sorry, this is just a comment that I could take very harshly. Sus. Sus. Power supply sus. It's sus. I did sus just because I was thinking of 3-letter acronyms that I could put there. And also, this is a reminder that this is not a professional product. Although we are treating many of the aspects of this as professional and trying to get them as trim and proper as possible, it's also just some bullshit that I'm putting together in my shop for fun. So we got to keep the fun. We got to keep the fun going, you know? Otherwise, what's left? Yeah, have they heard of offline stuff? You could get a couple tape drives and put your collective species memory onto that. You would think that, like, the Federation would be like, yeah, we got some hard drives sitting around. Let's replicate them and put them in the cargo bay, and then you guys can load up all your dumb brains onto it. You weirdos, you little weirdos. But instead, they were like, let's steal an entire ship. And then the second time somebody tried to steal Picard's ship, he went fucking apeshit on them. He threw Tuvok into a deadly beam sweep. Well, he didn't really throw him in. He sort of decommissioned Tuvok. Did I say Tupac? Did I say Tuvok right? I hope I did. Anyway, he frickin' knocks out Tuvok. It wasn't Tuvok at the time, probably just having a bad day, and allows him to be deadly. Allows deadly exposure. Yeah, Tim Russ is the actor for Tuvok. Deadly exposure to a barium sweep that mysteriously has to be done on starships and was never mentioned before or after. Well, yeah, Paris was actually supposed to be Paris from the, I was going to say Jedi Academy, from whatever, San Francisco. Starfleet Academy. They were supposed to be the same actor, but they couldn't get the rights to it. So they made Tom Paris, the white breadiest character in the world. I don't remember what his actor name is, yeah. Let's try a different color. Down with pink. Pink is actually in front runner for the LED color. I wish I had a deeper blue, but let's just deepest bluest. My head is like a shark's fin. Let's put blue LED in on this. Oh, look at that. The effects of the soldering iron. I have ground connected, so that was a ground loop into a diode, causing a little bit of excitation. Okay, not helping. Not helping. Where's my desoldering wick? Desoldering wick just takes advantage of surface tension in order to remove solder from a pad. So how cool is that? Thermals have a good sum of pink. Well, so actually this color palette here that's being used on the thermal imager belongs to Lepton, who makes the FLIR imager, the forward-looking infrared imagery. If you see something on like YouTube and stuff like that, and they have this color palette, you know that it is a Lepton device that they're using. Now, it might be that the core for the thermal imager is the Lepton device and another company is selling whatever plugs it into like your phone, for instance. But that color palette belongs to that company. It's kind of interesting that way. Pink, ultraviolet, white, orang. Orang seems like a good idea for the color of this indicator, but this blue LED has a lens on it. I don't know if I really trust it behind there. Let's try it out. I have a couple different varieties of LEDs. This one is designed to transmit light. This one is really good if you're trying to illuminate a button. A button! We'll give it a go. These are fairly bright. The LEDs that I bought have, actually I don't know about the blues, but I know that these are really good at transmitting. I have ultraviolet LEDs. You're asking for a black light LED. I have them. But they're not going in this because it's plastic. And ultraviolet is bad for plastic. It's just bad for it. Come on. These are kind of a little bit more difficult to work with because they're large and they have these weird tabs. So they're a little big for this type of circuit setup. And I probably should have moved that resistor away quite a bit. Also, I'm messing it up very plainly. Oh my God, how bad is it? This guy can't even solder stuff. Oh, it's because this. There we go. He's dog shit at soldering. What's wrong with him? Starting to smell like burning stuff. What's burning? Oh, not me. Maybe somebody's cooking something. I don't know. There we go. That's not a great job because of the size of the LED, but I think it'll still illuminate. I think it'll still illuminate. I don't know. How's Friday shaping up for everybody? My head hurts. I got a big headache today. Trying to drink a lot of water at it, but... All right, what is that going to do under 5 volts? It's pretty bright. Really doesn't look that bright from here, though. I don't know why these just don't seem to be very bright today. Usually these will like hurt your eyes. Is it getting hot? It's getting hot. What's happening? I think maybe I shorted something out. I think maybe current's not getting through the right part of the LED. The thermal imager. Wait, why isn't it? Oh, there we go. That's the one that I want. The thermal imager, unfortunately, skews the hottest and the coldest within its vision. So it will slide the color palette around. So the temperatures that you're seeing, you know, they look the same as if I turn on like a heat source. Like here, look. Fire. Fire. Oop. There you go. Fire bad. Rah! But yeah, you can see how everything gets more dull when there's fire. And then when there's not... Can you turn this thing off? Oh, yeah. When I get this out of here, everything skews back. Anyway. That wasn't as extreme of an example as I thought it would be. It's fucking hot down here. I'm sweating. All right, so what was wrong with my blue LED? Like, it just was fucking up. I guess I gotta, like, clean this up a little bit. Just accept the damn compliment. No! I'm using it as a teaching moment. Everything's a teaching moment. All right, so from here to here to here, let's push this LED, or push the resistor over. Okay, let that solidify. And then let's get this fully out of here. I'm gonna use a new blue LED because for some reason this thing overcurrented and became very dull. Oops, wow. Okay, well, I guess that was a little convenient that it flipped like that. Get out, get out, get out of my circuit. I'm kicking you out. Leave, please leave. Oh, that's awful. Yeah, my folks still do that because they were the oldest in both of their families, so everything is a speech. Also, how's it going, Fadanon? Good to see you. Ah! Everything is ruined. Why did it light up? Because of the difference in potentials from the ground that's at the tip of the soldering iron and the ground that is in the power supply. I have ground still hooked up to the LED. So there was enough voltage differential to produce a very small amount of light. But that's what's called a ground loop. Yeah, it did. It illuminated just a little bit. I'm slowly turning into a speech person. No, it's taking over. Must teach. Well, fortunately for me, streaming on Twitch is very speech person friendly. All right, I'm getting a new blue LED. I got stacks and stacks of these things. So it's better to not try to continue to use a damaged LED. I think maybe something shorted due to someone's sloppy soldering. Whoever got here before me did a pretty sloppy job soldering that. So we'll put a slightly better solder job on this, and we'll see how much illumination we get out of this thing. Because these should be much brighter. These should be like painful. Oh, I don't know which end is positive and negative. Apparently there's a green mark on this that I never see. But that T there, okay. There's a Thai food place around here that has some really weird tasting, like super hot oil that they use. And I don't like it, but for some reason, I like crave it. I'm like craving it right now. I don't understand. JMez TV. JM Easy TV. Thank you for subbing for 6 months with a Prime. Hey, I really appreciate that. I know I like to shout out everybody who streams on Twitch around here, and I discovered that what is it, Last Miles streams. I don't get, like, my head is in the sand. Like I don't see a lot of you know, people that filter in here that run their own streams, and so I apologize if I don't shout you out, because I just don't know what's out there. I intend to give everyone credit, especially if they have a cool stream. Where are Army Tweezers? And then if somebody big raids me, I can just totally fucking ignore them. We haven't had a big raid in a long time. I don't know if we'll get one ever again. I have to keep weird hours in order to do that. Weird hours that I can't keep, especially not today. There we go. Still the sloppiest soldering job that I think I've ever done, but at least it's more reliably contacted where it needs to be contacted. Both of my parents, the older of their family, my grandparents were also the oldest of their family, and it was oldest grandchild. Oh my God. Yeah, I'm the second oldest of the grandchildren, luckily. And we are there's a big difference in age. Thing is, me and my two cousins look exactly the same. We're like the same person. And these aren't the cousins that show up in chat. I actually do have a picture that I could show you guys of this. We're like the same people. It's really weird. Like carbon copies of one another. Hold on, I gotta get it separate from the... We're the same person. It's really weird. Yeah, the problem is it's British genetics that make us all Sasquatches. We're all fucking Sasquatches, man. It sucks. So this one has a lens on it. So you can see the effect of the lens is that we don't get a lot of illumination on the edges, in spite of all of the diffusing that I've done. So I think the other type of blue LED is probably the one that we want to go for. So let's get the other type of blue LED. And if it's this brightness, I'm happy with it, because this would be visible under low light. I don't want it to like hurt to look at, right? The West Virginia mountain folk, oh dear. Oh my goodness. Yeah, we got the full experience when driving on back roads in West Virginia. We got people out in their front yards showering, like a naked old man in his front yard showering. Up in the mountains. Yeah, purple is pretty strong. Purple is pretty good. Blue, for some reason, is underperforming, and I think maybe it's the diodes that I use. I've got the power supply at 5.08 volts, so this should be screaming bright. I don't understand why it's not. Maybe I've just got a bad impression of these. Let us get a different type of blue. These LEDs are pretty much disposable because I have tons and tons of them. Billions and billions. I don't have tons of these. I got these blues are... Wow, these blues are really fucking small. I don't know if these are gonna... Jesus Christ, this thing is tiny. Look at this little bean. This little bean of an LED. It does have a lens on it. I do have other blues, but I only have like 2 of them. And they're a little bit larger. Oh, I thought I was burning myself for a second there. Pulled my arm back from the solder station, and I guess I must have tweaked a nerve or something. One, two, one, two, one. There we go. So if I did the lensed ones, I could put 2 behind each one, and that would illuminate it evenly. Which, you know, might be a strategy, but that's a lot of LEDs. Then again, I got tons of these things. I think the arrow points with current flow, so it goes like this. All these little techniques for flipping stuff over. Oh, I should probably clean the pad too. Get off. Get off of there. Both of the brews, by the way, that we did the other day, last week before, those are bubbling away. I'm listening to bubbling in the background right now. The mead is probably on its way to be an extremely strong wine level amount of like 20% alcohol by volume, and the stout has slowed down, but I think it's still bubbling. And the temperature swing in here didn't help those matters. I just want the solder to hold it for a minute. There we go. Because I'll be depositing flux with the new solder. So get this in there. What time are we at? Yeah, we're at a good time. Look at that illuminating the wrong way. I don't know why that's happening. How could there be a potential difference across this thing in that direction? I don't understand that. Because the power wire is not hooked up right now. Oh, yes it is. Never mind, that's why. There's like a strong 60 hertz wave on it. All right, how bright is that thing when we power it up with 5 volts and a 1K? That is a lot brighter than the other one. That's a lot smaller. That is a significant amount of brightness from that. Whew. These I bought for the RC car project. Why is the 1K heating up so much, though? Oh, no, it's not. No, it's not. I thought I felt a lot of heat, but I guess it's doing okay. Actually, it's doing 1K. Okay, spring arm. Let's see what this looks like back there. I can fit a lot more of these there, but oh, I don't even need to. Wow, that's actually really nice. That is actually really nice. Just one of these LEDs, and it is a deeper blue deepest bluest. My head is like a shark's fin. Yeah, it's a nice deep blue. Yeah, I think that's gonna be it. I think that might be our indicator. It doesn't look great on camera though. It looks better in person. It's deeper than you'd think. I did have some Adafruit ones that were a little deeper. I need like a deep blue LED. I don't know where to find one. I also probably could have just printed this with blue filament. The clear blue that I have, instead of using the clear, I could have used clear blue, and then that would have shown up less on the side, and it still would have allowed all the light to get through. But no, I think we just deep blue them. Green for good. Green for good, maybe. It really is just going to be a singular, like, on or off, right? I'm not going to put RGBs behind it at all, although that would be pretty nice. I could use the... No, I don't want to do that. Those things get hot, too, so... Yeah, deepest, bluest. My head is like a shark's fin. Red for good. True, true, true. What do you use? Elon Snusk. Elon Sus. I use the fucked AT Tinies to remind myself of the fleeting nature of life on this planet. We destroyed something beautiful that existed in this world, and it is no more. Some of them might actually still work. Some of them just need the 12-volt programmer that I've only recently gotten. But these mostly have been fucked just by reverse currenting them. I keep them because it's comedic, the amount of fucking AT Tinies that I've blown up. I'm very angry at myself for all of the little mistakes that I made. See, we made a device that was on the LIN bus. We put an AT Tiny on the LIN bus, which is a 12-volt bus, and these AT Tinies really don't like to be reverse currented. The AT Tiny is a nice little platform. It can run a lot of moderately complicated code and do a lot of like signal stuff, and it's really quite powerful for only having 8 pins. You don't have a lot of I/O on it, but you can run a port expander if you want and get more I/O. They're very small, and they're just kind of a fun little light microcontroller to put in stuff. But they can be a pain in the ass to work with. There's not a lot of pins, so one of the pins is a reset or an I/O pin. And in order to make it both, in order to reset the AT Tiny 85, you have to have 12 volts on that pin. But if you put 12 volts anywhere else on an AT Tiny 85, it'll explode. And it'll quite literally explode. I had one of them actually bake. It was letting out smoke from the top, and yeah, it was a bad scene. So anyway, we keep them as a joke. There's a lot of little joke things that we do around here. I don't like emphasizing the jokes. They just happen. This one should be red. I mean, I could alter the... I could do different colors out of these. I don't want everything to be RGB rainbow. I don't want everything to be RGB rainbow. I hate RGB rainbow. I don't know. This is a good... Blue's like a good color for this, but I don't know. Maybe orange. Maybe we do orange. Orange would be a little cooler, and it'd be less harsh. Yeah, I think I don't do blue. We're not stuck in the early 2000s, right? We're not gonna do blue for everything. Everything doesn't have to be blue. We use orange, orang. Let's find an orange LED and put it in there. So disconnect. Disconnect. Bonk. I mean, red would be pretty good, actually. You know, red would actually be pretty good. Maybe I will do red. Let's look at orang first. CYMK. I think there are some chips that do that. I think you can get better tones out of them. RGBW is also a really good one to do, because then you've got the white LED there to kind of complement the light levels of stuff. What doing? Okay, I remember. I remember now. I remember everything. I remember. Remember. Simba. Nope. Got him. Got him. Now we'll put that aside for later. Okay, bye. Have a nice trip. See you next fall. Okay, it's actually right here. Oh well, it goes on the floor. Bad LEDs go on the floor. Orang. Let us try orange. Orange is actually a brown. Did you know that? Because Technology Connections did a whole episode on it. It was pretty fun. Okay, I need to flip this over. Okay, there's the T. So the long part of the T goes towards the power, which is sort of the opposite way that the diode symbol works, which is kind of annoying. That ruins that sort of mnemonic, because then that mnemonic becomes that but the opposite in your head, which is not a good way to remember how to hook up something that will explode if you hook it up wrong. Actually, they changed the epoxy in LEDs, so they kind of just burn out. That was a sad day when I discovered that. Back in the day, my brother and I would take red LEDs and we would hook them up to 9-volt batteries, and they would fucking pop. They would like snap. They don't do that anymore. They don't do that. It's sad. Come on. There you go. I think that's soldered. It doesn't really feel like it's soldered, though. It doesn't look like it is. Solder doesn't go up over the terminals. I guess that is. What about you? WBU. All right, let's give this one a shot. See if it explodes. Orang. That doesn't seem like a lot of orang. It's a little bit of orang. All the heat from the solder is still in there, so I can't tell if it's going to explode. That is a lot darker than what the camera says. And it doesn't seem to be enough light coming out of it. Is my 1K actually a 10K? I think that might be the case. Let's look at this resistor. No, that's a 1K. Huh. I need to go down to 300 ohms. I mean, it is under a lot of light. But boy howdy, does that not penetrate the plastic as much as I would like it to. That one sucks. All right, no orange. Red would probably be best for lights that I observe on the wall. But red, I don't know. I don't know if I like that. But we'll try one of the reds. The unlensed ones. The ones without the lenses are better. What's that LED? I guess that's red, I don't know. Red LED. That's here. And then back to this view. I really should just set these all up on one board so that I can just run through them and see what they're all like. But I don't know, this is kind of the fun part of the project, right? Where we get to do the appearance stuff. It's also possible that this thing didn't have that great of a connection. No, it had a good connection. It looks like it did. It had a good time. Now die. Flux gets on the tweezer tips and then it causes stuff to kind of knot. What about yellow? Yeah, maybe not. Yellow's probably a bad idea. Why did I pick that out of the box? Oh, that was an LED. Yeah, it's a ground loop. When you got like 60 hertz running from two different grounds going different distances, there's a difference. Actually, I think they all should be connected somewhere, but anyway, I've got bad ground looping issues, especially with my speakers. When I open up Fusion 360, the computer power supply is able to put enough current through itself that there's a heavy buzzing out of my speakers. I gotta solve that somehow. I don't know what I need to do. I've got them on like the same, they're on the same power, they're on the same grounds, all that stuff. And I've got filters. I bought like a specific plug strip that had audio grade filtering in it, and it still buzzes. Reverse polarities. Did that cause that? No, I think the polarities are correct. I think they're correct. Oh, you're Star Trek memeing. That also does not seem very bright. Deep in the heart of Texas. I need multiples in order to get this bright enough, it seems. Or a much smaller resistor. What if I go to like 6 volts? Get over to that. 6 volts. That doesn't appear to be doing much. Different phases. Yeah, I don't know what it is. It's some nasty ground loop that I've got going on. Yes, the magic deflector dish. I would need multiple LEDs in order to make these accomplish what the one blue LED was capable of doing. Green might show through pretty nicely. Yellow, perhaps. I don't know. All right, I'm gonna have to make a decision about what LEDs I want to be behind this thing because red just wasn't cutting it. I mean, I could do blue and something else. Nah, that won't really show through. White, of course, would illuminate it ridiculously. Warp foam. There was an episode, and that was Starship Mine. And that's actually the one we were talking about before, where they were stealing warp plasma as like the magical MacGuffin. They wanted to put the warp plasma in from the core into a container. Strange. Very strange. I don't know how that's supposed to work. Why that would be a special substance that you would steal. You would think the core is just like generating that kind of thing and not like doesn't have it as like a supply. But I guess they just wanted to use the warp core sets. Okay, like that. Clam chowder. I was supposed to have clam chowder for lunch. Yeah, what's going on here? I forget which one this is. Is it upside down? No. No, try it up. It's right side up. Come on, come on, come on. In there you go, in you go. That looks all effed up. Oh, I think that's contacting enough. The smiley face and laughing. Yeah, that was a Crusher episode, wasn't it? Oh my god, that is a dog shit amount of light coming out of this thing. I think I fucked something up. Why is this so bad? It's like just not, I mean, it's good if like you're doing like an indicator on a board, but it's so messed up. It's like not a lot of light, and I thought these things were much brighter than they are. Was that a Brandon Braga episode? I think it was. He's good at that kind of stuff. The sort of existential weirdness and time moving in a weird way. I mean, like, while it works, there's not a lot of light coming out of the front of this LED. It's really not that bright. So something, I don't know, something's messed up. And it's you know, there's only a few, only a couple pieces of this equation here. It would be the resistor that I'm using, the LED being too low. There's no discernible current coming from the power supply. It's not reading anything. It reads 0. So, I mean, I could do a calculation to give it 20 milliamps, and it would probably end up being a 300 ohm resistor. Kind of odd, though, isn't it? That it's, I mean, the other way to do it is just to pump up the volts and then current limit on the power supply. Times scape. Okay. I always forget which episode that was, because there was a VHS in Blockbuster, and I think it was like A Boy and His Bomb. It was some old crappy movie, but it had a nuclear explosion cloud that had a smiley face drawn in it. I never watched the movie. I always wanted to. Yeah, yellow sucks. Red was too dim. Green was... Blue worked. Blue was the only one that seemed to work. The ones with the lenses, pink was okay. U-violet is out because that's going to damage the plastic. Didn't try any of the white LEDs. I got 2 bins of white LEDs. I don't want the indicators to be white illuminated. A laser disc. Man, those things were huge. Oh, they were so cool. I thought orange would have done better, but orange is just as dim as yellow here. Now, this could have to do with the resistor that I use, and maybe jumping down to a 300 ohm resistor would pop that brightness up significantly. And yeah, if I were to use these, it would be 2 side by side. If I were to combine any of these colors, I don't think I would get anything out of it. Maybe blue and red, but red is so much, or blue is so much brighter than red, especially in how it registers in your brain. They don't really color mix all that well. Yeah, white and yellow. Because, yeah, I was thinking about that. Like, how can I deepen the blue? I guess, I mean, alternatively, if we really want to blast these things, I could put an RGB LED, a digitally controlled RGB LED behind all of them, and then these would be extraordinarily bright. I really want that, though. I got them in the LED bin. Hold on, let me go get them. Let me go get them. Let me go get these LEDs out of my bin. Out of my creepy LED bin. It's all the way over here. I gotta move a box full of springs in order to get to the bin that has all the LEDs in it. There. Alright, bring that over. Bada bing. This is where I have a lot of the derelict LEDs. There was an illuminator that I bought for my Mark IV VW, and it had the best LED that I've ever owned. It was a bunch of these little deep blue LEDs, and they were kind of oval shaped. And I've been chasing that dragon ever since. I put those LEDs into some projects that I've had over the years, but here's the board with them on it. These 3 LEDs right here, all that I have left of that VW illuminator. And one day, maybe, just maybe, I'll be able to find where these came from and be able to buy my own. Because these were amazing. They're super duper dark blue. Let's see if I can show them off without blowing any up. These LEDs same size literally today. I was rated for 150 milliamps. I run them at 20. But I guess you could go down to at least 300, maybe even 100 ohm. That might be the case with these. I don't really know much about them. They came from... I'd have to look through my order history, because I think I ordered these a couple months ago, so I'd have to look through the order history and see how many milliamps they are designed for. Because, yeah, it could be a situation where I'm very much underdoing it. Oh, God, this would be so bad. If I ran RGB on all of these... It would blast the ever-loving crap out of the front of this thing, though. That's the only problem, is these are way too powerful. These hurt your eyes. No, I'm not going to do that. Not going to do that. No, sir. Could run these. 3-watt LED. These are 12 volts. 7, 8, 9... 10, 11, 12. And they have diodes on them, so they can be run in either direction, but... Uh-huh. Yeah, uh-huh. Yeah, no. Just no. Nope. Not gonna happen. Not gonna do it. You cannot convince me to run the 3 watts. We use these for the globe project, the big globe that we put RGBW LEDs all around. Oh, it's hurting my eyes. All right, nope. These are, so you get the driver for them, and you can actually pull up one of the pins, and then you have a pin that can control these with PWM. And so I had to modify 600 of the fucking things in order to make the RGB LED globe. All right, let's go back down to 2 volts. 5, 4, 3, 2. Oh, it's at 3 volts. I think 3 volts is okay for these, right? These do not have resistors on them, but they're all connected in parallel. So let me go to 2 volts, and I'm going to limit the... Well, I won't limit the current. We'll just go to 2 volts. That's about the voltage drop of a blue LED, right? And so I don't have a lot of leads on these. I really need to find these LEDs, and I don't have any information about them. They were used as an LED illuminator for a VW, because VW has that brilliant deep blue dashboard. This matched that illumination, and it was really actually fucking cool. It was really, really nice. I've used these on a couple projects, and I always make sure to tell the person that I'm incorporating this into about it, because I'm like, this is one of the 12 LEDs that I have that I really, really enjoy the coloration of. They're really nice. So the question is, how do I hook up this board? I guess I could use wire, but I could also just tap the terminals. I think one is over here. So that one is, where's the toilet bowl? So when you're trying to figure out what polarity an LED is, you're sexing the LED. When you're trying to figure out what the LED is, and you've got the epoxy coated ones, you have 2 parts to the LED in there, in the epoxy. One of them is that toilet bowl looking thing, and that's typically negative. Positive is typically the little post that comes up. And there's a little gold bonding wire that connects it to the chip of the LED right next to it. Pretty cool. But yeah, when you have an LED that you don't trust and you have a lab power supply, you limit the current on the supply and you bring it through voltages until it illuminates. Or you can take a multimeter and you can put it into LED mode, into diode mode. Typical multimeter will be able to put the forward voltage through that diode and tell it to you on the screen while also conveniently illuminating the chip. So without full brightness, you can tell what your green LEDs are and what your blue LEDs are with a multimeter. Yeah, it puts about 1 milliamp through, and if that's not enough, then it's not doing it. Negative and positive. Oh, I see, it's these two. How can I tap to those and show it to you at the same time? Oh, I could just do it here. Okay, cool. So which one is negatron? Which one is positron? Boop, boop, boop. Those are going to the square lead. Square lead is probably pin 1, which I can't tell which one is which. Square lead is positive. So that would be, well, if they're all connected to one another, I probably shouldn't just sit it on that. Which one goes to the square lead? That would be the one on this side, but I don't think, oh, I think they're doing some kind of like a series thing too. Okay, this is all over the place. This shit is all over the place. I'll just try to illuminate like one of them for you. I'm looking for leads that I can take advantage of. Where does that one hook up? Actually, I think it hooks up to the center, so I can just do that. Square lead positive, so positive on the right. Negative on the left. Use diode mode to test analog meters. Most will have a total deflection of 1 milliamp. Oh, neat. Didn't know that. Nothing at 2 volts. Hold on. Let me get the multimeter. Multimeter to the rescue. Preach what I'm practicing, or wait, the other way around. Okay, how many volts is this thing gonna diode mode at? Also, you can test the polarity this way. I think there might be no connection. Huh. Hold on, use it this way. God, it's fucking hot in here. I'm like hot and cold at the same time. I hate it. OL, LOL. Try it in the other way. Oh, I almost got it. There's a lot of corrosion on this board. No? Okay, other way around. Interesting. Negative is always the bigger thing in the LED because it's usually connected to the ground plane to sink heat. Yeah, that's what I led with. That's basically what I'm saying. The toilet bowl, the larger object inside of the LED. Yeah, that's the one way of thinking about it. I took some of my pad up with me. Just give me the damn LED. Give me. Owie. It's hot. LEDs are warm. Get the tweezers in there so I can pry it out and heat it up without my finger being part of the equation. Jesus Christ. Oh, that fell and it went somewhere. All right, now we gotta find it. My precious LED. It's here, it's local. This goes back in the bin. We got a lot of bins out today. I think we've kind of done a lot of stuff. I do wish it was easier to take apart these pods because I want to get the microcontrollers out of all of them. They all have a syringe in them though. God, the new pods are freaky though because they've got a syringe that's being held back by a piece of plastic that's barely up to the task, and it'll be released via like with tons of tension, only to smash a needle into your body. Where did my LED go? Hello? 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 Why are you reminding me? I'm horrified again. It's so crazy that's what the device is. I mean, there's a fun little game where you get to strap the pod to yourself and tell your phone that you want it to fucking punch a needle into you. Fun little game. It's fun. I fucking heard this thing drop, and now I don't see it anywhere. I definitely heard it drop. Where the hell is it? Where's my precious LED that I love? Cursed dirty desk. I think I need to get a new mat. When I wiped off the other mat, it kept a lot of the paper towel that I wiped it with. All right, I'm trying to dig down here and find where this LED went. There it is. Okay, good. That there, this here, wire cutters in here, spring tensioners somewhere. Okay. Mechanical mosquito. You're not supposed to hit blood, right? You don't hit anything that carries blood, because you're supposed to get it into the interstitial tissue. It absorbs too quickly in blood. No, it actually it has a delay by design, Pseudomaze. What happens is it ticks for a little while because it needs to advance that cylinder, and when it finally advances it far enough, it releases the little thing that then snaps. So you tell your phone that you want to get stabbed by a needle. It's not, I don't think there's not enough voltage in this in order to light it up. 1 milliamp isn't doing anything to it. So you hit the button on your phone to say, hey, could you just like stab me with a needle? And then you hear click, 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 click. You don't know which click it's going to happen on. Click, click, snap. And it's like, ah! It doesn't hurt, but it's surprising. It is surprising. Are these fuckers 12 volts? I don't think they are. Voltage 3. There we go. So I guess that's not that special, but if you see it in person, it is kind of a neat deep tone of blue. I mean, it looks better in person. There's a lot of purples to it. I should have bought purple LEDs. Why didn't I buy purple LEDs? What's wrong with me? It's not so much Russian roulette because you know it's going to happen. You just don't know precisely when, right? So, no, that's AC okay. I don't know why you guys think it's sauce. That's AC okay. And there's bus okay, 24 volts okay, 12 volt okay, and then 5.1 for the Raspberry Pi. So what I don't like is the way that these are diffusing in kind of a spotty manner. If you guys could see this without the camera doing color adjustments, it's actually a really nice deep blue that's illuminating it. It is leaking out to the other areas of the thing, but yeah, this is like a really neat color of LED, and I want to find more of them. I just haven't been able to. Problem with deep blues is that they're not bright. So sanding the back of the plastic. It's actually the spottiness is caused by the bridging over this, because we have a millimeter deep of one color and then it just... Why are you looking at me? I hit the wrong button. Now I got a browser window in front of the... Okay, hold on. That's a little close, but I guess we could view it up close. Yeah, so what it is a millimeter of plastic, of black plastic, and then bridged clear over top of it. So the bridging is what kind of fell down a little bit, and that's where the spottiness comes from. So, you know, if my bridge settings were better, it would be a little better, but looking at it in person, it's fine. It's just like this, it's a little bit sloppy, but that's okay, because these show up nicely when you put a little bit of light behind them. I do have to run like a bridge clinic on my printer, but without a fan, it's just not worth the trouble. All All right, let's put a different resistor on this thing. Let's put a 300, maybe a 200 ohm on this thing, which means I gotta find it, which means I gotta go through these bins and find a 200 ohm resistor. 2.2M. Well, that's not gonna work. Yeah, I don't need to know what my numbers are while I'm going, but it's nice to have people here on a Friday. It mostly correlates to Rabah's not streaming. That's why anybody was here. These are the kinds of people that would watch some weird Swedish man play Hoi 4 for 27 hours and not complain. I don't know what goes on inside of those heads, but it's definitely not functioning normally. I think Fadanon linked me there. I think he linked me there. I think I know about that site. Now I use PETG, and all my temperature settings are all blown up to hell. I print on the surface of the sun with PETG, and it's brilliant. And, you know, it makes this kind of stuff, and it makes it strong. We are strong. We do complain. See, I told you they were here. I can't. I turn it on and I see Hoi 4, and I'm just like, I'm just bodied. I instantly pass out and hit my head on a coffee table. Like, okay, let's see what Rabah's is doing. Dead. Andrew Ellis. Okay, maybe that's the one you linked me to. I didn't see the GitHub one. I seem to remember the GitHub one though. All right, 200 ohms. Where did I put the resistor? Oh, it's right there. It's right off camera. It's hiding. Oh, looks like I called them out, so they all left. I'm calling you out. Yeah, linking me right now is pointless because I'm not going to have the time or the attention span to even look at it yet. But I will ask when I get there, though. But yeah, for anybody else, there's the link. Well, wait a minute, huh? Oh, right. So the numbering scheme on the resistor chips, if they're large enough to have numbers, you can see there's multiple. This one has 4. This must be a precision resistor. With a precision resistor, you get more digits, but this one has 2,000 written on it. It is a 200. Oh no, this is not precision. Never mind. It is a 200 ohm resistor. So 200 with 0 zeros. So that extra 0, it does not make it 10 times more resistant. That extra 0 is indicating that there are no zeros after the zeros, after the number. So 2001 is 2K. 2000 is 200 ohms. I like that system. It's a good system. Way easier than friggin' cryptic color coding. That is not a lot brighter. It's really not that much brighter. The null terminator. Yeah, there you go. And the null terminate. Okay, let's see. Here go, you're back here. Maybe it is a little brighter. Orange is still way terrible. I mean, red would be more funny. But orange is sort of the color of the indicator lights, the little spinning lights on Burn the Subs. So, I don't know. But I can't get enough orange out of these LEDs for some reason. Oh, this is at 4 volts. Hold on. Voltage 5. That's 6. Now it's 5. Oh, that is actually a lot better. Wow. All right. There's all that light we were missing, huh? I'll have to calculate them individually off of the thing, but orange kind of works. Makes it look like it's from the 70s, though. I guess that's partially my fault due to the font and the oval. Yeah, due to the font and the oval. I think I want to use something other than orange. But it does look pretty good. I don't know. Blue look like neon indicators. Yeah. Yeah, that you'd see in like an old power plant or some shit. Pink would be the only funny color that we have. White LEDs, of course, would make it look like it's just trying to be a bulb. Yellow sucks. Blue is 2001. Orange looks like the 70s. Red would blend into the background but be okay. Pink was the... Oh, blue was the first tiny one. Yeah, the blue tiny did really, really well. I mean, green would... Okay, that just flipped the whole lid off. I'm gonna flip my lid! I hear people playing with Corgi upstairs. I want to go see. I want to go play with the Corgi. Okay, so I'm going to make a decision on this at some point, and then we'll put an entire circuit board behind this panel right here. From there, I guess I can hang the alternative voltage power supplies off of this piece, or I can come up with a different like bracket that I can put on the rail in order to hold the... Why do I smell fire? Oh, because this thing... I was burning some wire over here in the background. I don't know if you guys saw. Yeah, you guys probably did. If you look at the clip, you'll see these wires heating up as I'm talking to you. Look at the warm wires. Oh my goodness. Probably should have let that play out and have a little explosion. I have the power supply set to like up to 10 amps right now, so it's able to cook stuff. I'll have to decide on what color I want these indicators. I guess that's why everybody falls into the RGB trap, is they don't want to decide on a color scheme for something, and so they end up with RGB LEDs, and then the default pattern of them is rainbows. So everything is rainbow illuminated all the time, and people are too dumb to go in and choose a color scheme and make something that looks cool. Eventually you have a light emitting resistor. I've had those before for sure. I've had light emitting ASICs before. There was one of the chips on the RC car was it was like a MOSFET, so it's just like designed to switch large loads of current, but the current or the voltage was out of spec, and so this thing was lighting up the little... You could see a little square under the cracked epoxy that would light up like orange as you tried to use it, and it still worked. It's like, oh my god. So anyway, bus sus 12 volts, 24 volts. We'll get this thing done. I'm gonna have to cut out a circuit board for it. Maybe we'll work on that on Tuesday, which is when I will be back to projects. However, I will be streaming on Saturday. I've got my whole setup ready to go. I've got the 2 horsepower wheel, all that stuff to the left there, and the 3D printed shift knob. And I've got my summer car on cue. We need to win that rally again. I need to do it one more time, and I can get third and still get enough points to get into the senior rally. But I would like to get into the senior rally because I think it would be easier to race against senior citizens. No, I want to get into the senior rally to see what the times are like and how incredibly competitive it is. I don't think I'm going to end up doing engineering on the wheel. I might uncover something that I want to improve on the wheel, and then that would unlock another long project. But I don't want to... I think the wheel's ready to go. I think it's ready to go. I think it'll be okay this time. But yeah. We did some cool stuff with Omnipods today. At least we took one apart. Heating... There's the clip. Nice. First place on second day is 11:20. That's under 5 for both... Or no, sorry, that's 5... Well, 5:30, right? Gets you to about 11. That's a competitive time. I don't think I can... I mean, we've done a little over 6 minutes, I think, for both of the sections. So I don't know if I got that in me. We'll have to try it. Dakar Desert Rally. No, I haven't. Well, yeah, running at as lean as it is bad. So I think I need to do a little bit of... I mean, I could put it on the dyno and see what I get. I could try that. The dyno doesn't auto-fix stuff, right? You need to tune it once it's on the dyno. But I'll figure it out. We'll see what we get up to, because remember, where we are in the game is just after the rally. So we need to kill a day or two and then go to Flitari's. So that's what we'll work on when we get back to it. But I'm still going to use the wheel because that's super fun to ride around with. I mean, the wheel makes driving just like a pleasure in that game. So Yeah, it's okay. So it's just like a regular dyno. It doesn't fix your car. Because my summer car works in all kinds of different ways. You could go onto the dyno and it could magically fix your car, and that's just the way the game mechanics are supposed to work out. But I guess it's more in line with how Topless Gun put together his game, that he would say, well, it just does what a dyno does. Looking good for sim racing. It has parts that can break, and if your setup allows for it, you feel a wheel is going to fall off. That's pretty cool. I think the direct drive would allow for that kind of thing. I just wish more games were my summer car likes, because the level of fixing stuff feels just more real as somebody who actually has worked on cars. That reminds me, I got to make an appointment to bring my car in. I need to actually get somebody else to work on it because I haven't had time. If I had some kind of a portable setup, maybe you guys could be in my pocket, then maybe I could shade tree the car with chat. But as of right now, I just haven't had the time between you guys and the dog. So we're getting used to the puppy though. She's awesome. And I hear her barking upstairs. So I'm going to take this opportunity to say thank you guys for watching. I really appreciate the slightly inflated numbers from Rob Oz, because he's dead today. And from, did we get a raid today? I think we did. Oh, wow. That's a lot of follows. No, that was yesterday. We got a Last Miles raid with 80 people. So a lot of you are still left over. Bald Engineer raided with 58. There it is. Yeah, it was Bald Engineer. If you guys get a chance, you should check out Bald Engineer. He's pretty cool. Pretty cool guy and doesn't afraid of anything. He gave me a big bolus of viewers during the middle time, and that sort of brought us out into the end. But yeah, that Omnipod is very interesting. I'm glad I'm not throwing away an electric motor every time, although it does kind of seem like they could have just put like a cheap electric motor in it. It's a very interesting system, the way it works. Car dentist time. It will be like pulling teeth when I get the bill. MSC isn't really a sim racer. It's more of a car ownership sim. But the sim elements in it are so strong that it kind of is. It kind of is a sim racing. It's a really good rally racing simulator for a country bumpkin type rally race. I would argue that it is a sim racing game, but whatever. Anyway, I will be back. I will be back on Tuesday, but I'll also be back on Saturday to play games. So I'll see you guys there if you can make it. If not, you know, I hate you.